Hello, am I audible? Hello, 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 hello.
Most of you sit here. Don't need people sit there. Those students who are not attending the session today, they will not be allowed to register class. Okay. You can announce. Please tell your friends. Those students who are not attending the session today will not be allowed to registering class. I'll put an email. Tell them a message. Tell them a message. We have no other work other than doing this. It is done for your benefits only. Right? Close your laptop, put down your mobile phone. Okay, after the sending message. Okay. And we have been watching your class. There are cameras there. When you come back next semester, the mobile phones will be configured. I'm very happy with the second year students. Why are you doing this?
Good morning. Am I audible?
Yes, good morning, sir.
Good morning.
Yes, sir.
I think screen sharing is not enabled for me. Can that be done, please?
Yeah, now Prantik, you can.
So now you are the co-host, so I think you can share your screen.
Yeah.
Yeah, a very good morning, all of you. I am Priyampada Subudhi, working as an assistant professor at IIIT CSE group, and I would like to welcome you all to this second day of our workshop on AI ML. And today the first speaker with us is Mr. Pratik Sen, who is an applied scientist and working in the Alexa automatic speech recognition group at Amazon. Prior to that, he worked in the domain of computer vision at Junction Controls, Honeywell Aerospace, AT Labs, and Oracle. He holds a master's degree in visual information processing and embedded system from IIT Kharagpur and has close to 7 years of experience in the industry. We are pleased to welcome you, sir, to introduce, to give your expert opinion on this AI ML in the computer vision field. So over to you, sir.
Okay, I think I need to be made the co-host again.
Okay, sir. Yeah. So are you able to share your screen now?
Yes. Just a moment. Is my screen visible?
Yes, sir.
Okay. So shall we start, or we are going to wait for a couple of minutes more?
We can start, sir.
Start. Okay. So good morning, everyone. Hope you guys are doing good. So I'm Prantik, and I work as an applied scientist at Amazon. You all might be knowing about Alexa. So I work in the automatic speech recognition team of Amazon Alexa. So today, we'll be talking about machine learning applied to the fields of computer vision and automatic speech recognition So even though my current work is in the domain of automatic speech recognition, I have like 5 years of experience in the industry in the field of computer vision. And very recently, I switched to automatic speech recognition. I have a master's in image processing, visual information processing, and embedded systems. So that involves the fields of computer vision and machine learning. I did my master's from IIT Kharagpur in the year 2015. So moving on to the agenda. So today we'll just briefly cover what is artificial intelligence, machine learning, deep learning. So these are the buzzwords which we keep on hearing every now and then today. We'll see what is computer vision and the main applications of machine learning in computer vision, even though there are a lot more to it. But we'll see what are the main problems that we are trying to solve both in the academia as well as in the industry today. I will also like to take this opportunity to introduce natural language processing and applications of ML in natural language processing. So this is a very related field, and like every day we are basically using applications that involve natural language processing. So I wanted to have this covered as well. We'll also see automatic speech recognition and applications of ML in automatic speech recognition. So kindly note, like before even we start, kindly note that I'm not going into any details of the algorithms. We'll just be talking about the applications. I'm pretty sure when you take up courses, you will be reading about these algorithms in much more detail. So coming to what is artificial intelligence, machine learning, and deep learning. Okay, so artificial intelligence is the bigger set, and within that, a smaller set is machine learning. And even within machine learning, deep learning is a small part of machine learning. So artificial intelligence is any technique that enables the machine to mimic human behavior. Okay, so the most simplest case of artificial intelligence I can think of is an if-else statement. So you write some coding, you do some coding, and basically I give you, let's say I give you the names of employees, their employee IDs, and their experience in number of years. And I ask you to basically group them into 3 groups: junior level employees, mid senior level employees, and experienced employees, senior most employees. So I give you the experience range, let's say 5 to 10 years, or 0 to 5 years is junior level, 5 to 10 years in mid junior level, and more than that is senior level. So you can use a very simple if-else statement to do that. So again, that this is the very simplest case of artificial intelligence that I can think of. Now, what is machine learning? So machine learning is mostly data driven. You collect lots and lots of data. You come up with a hypothesis. So hypothesis is nothing but a function that maps your input to some output, to some desired output, and you basically try to learn that hypothesis, learn the parameters of the hypothesis. So basically, when we say models, they come with some learnable parameters. We are giving, let's say you have to do an image classification task. You are passing your images as input to the model. It is giving you output. It is assigning some labels to the images, each of the images. So you are basically solving that using machine learning. This is a data-driven approach. And within machine learning, when we stack lots and lots of neural networks to do that same task, this comes to within the field of deep learning. Moving on. Now, first topic that I'll cover today is computer vision and applications of machine learning in computer vision. Again, like this is a definition from Wikipedia, but as we saw in the previous slide, artificial intelligence is something that tries to make machines mimic human behavior. So when we talk about computer vision, what we are trying to do is, so human vision is we see through our eyes and we interpret what we see through our brain. So what computer vision is doing is, in the field of computer vision, we see through cameras. When we have to basically replace eyes for a computer, it's nothing but cameras. So cameras they capture what they are seeing. What they are seeing that might be captured in form of images or videos, and you do some processing on the images or videos to interpret what is in the image, what is in the video, right? So this is the field of computer vision. Now, three very broad areas of computer vision. There are definitely more to it, but three of the most like common challenges that people try to solve is these: image classification, object detection, and image segmentation. So this is an image. On the left hand side, we have an image of a dog, right? So if I ask any one of you that what is there, you'll say it's a dog. If I have to make the computer tell me that it's a dog, that is when we say that this is the field of image classification. We are trying to solve the problem of image classification. Now, in the second image, the middle image, we have the image of a dog as well as the image of a cat. Now, when we have to say, when we have multiple images, multiple objects in the same image, we can say that, okay, there is a cat and there is a dog in the image. But if I ask you, where in the image is the dog or the cat lies? So what we can do is we can basically come up with an algorithm which not only says that there is a dog in the image, but also predicts the bounding box. Basically, it is surrounding the object with a bounding box. So this is called as object detection. So object detection is you are basically localizing where in the image an object is there, plus you are classifying that particular object. So if I say that within the bounds of this yellow box, there is a cat. Within the bounds of this red box, there is a dog, right? Now, again, in object detection, what we can see is there are areas within the bounding box which does not correspond to the dog, if we see here. So if we have to make more final level fine tuning to it, if we have to say like which pixel is the individual elements of an image, you can take it like that. So if I have to basically just tell that which all pixel corresponds to the dog. So that is the problem, what we call as image segmentation. So these are the broad areas most commonly, like people try to solve these three problems, but there are more to it definitely. Okay, so we'll see some examples which covers these three, one of these three basically sub areas within computer vision. And what best to basically start with? We all have smartphones, iPhones, Samsung phones, Motorola, and whatnot. So day to day in our daily life, when we use the smartphones, maybe with or without our knowledge, we are making use of one or the other computer vision algorithms. Either they are running on the smartphone itself, or they are running somewhere on the cloud, and you get served through the apps which interact with the algorithm that is running on the cloud. Okay, selfies are mandatory. Whenever we go to any party or anything, we definitely take selfies. And many times you would have observed that when you are clicking a selfie or you are using the rear camera of your phone to click some photograph, these kind of bounding boxes appear around the face of the human beings that are being captured, right? So this problem, we saw object detection. This is a very specialized case which we call as face detection. We are detecting human faces there, and this is called as face detection. Secondly, if I'm able to say that who is this person, if I'm able to tag that person to his or her name, if I'm able to say that this is Mary, I'm recognizing that person from the image, right? So that is called as face recognition. So now we'll see some applications. We all know that this kind of face detection, basically on your smartphones, what you do is you tap on that bounding box and it helps you focus on that particular person. So when it comes to cameras, not only your smartphones, but there are digital cameras, digital camera makers who use this face detection algorithm, which basically that is a very lightweight algorithm that runs on the device, that runs on the device processor, and that helps you focus, autofocus. Okay, so these are the main like industries where which manufacture cameras. So apart from smartphone manufacturers, we also have camera manufacturers which basically use face detection algorithms that are running on their processors. Now there is one more feature, like we talked about face recognition. Now, if you are able to recognize your face, you can use that to unlock your machines. It can be laptop, it can be your smartphone. So again, we have face recognition enabled unlock feature in many smartphones today. We have that in laptops today, right? So again, you can see that these are the industries. I might have missed many more. So these are the industries where like this algorithm again is running on your phone itself. It is not running on your cloud. There is a small face recognition algorithm that runs on your smartphone. These are very lightweight models and they can run well on your smartphones. Now coming to smart building solutions, like technology is taking us to like automating everything, right? So there was a time when you used to go to your college or office and then like put your fingerprint on the fingerprint sensor and it used to mark your attendance. Then, or like you swipe your access cards on the machine and then it marks your attendance or gives you access to the office premises or building premises. Now, like, and mostly this becomes a necessity because we know like post-COVID, how much important like contactless access control has become, right? So many companies are investing a lot to come up with vision-based facial recognition system for access control and attendance system. Basically what it does is you have a camera that is fitted at the entrance or like at each door. And what you do is you go stand near the door, look at the camera, it clicks few photographs of you, and your photo is already there in the database. So it basically uses some machine learning algorithm to compare those two images and say that, okay, if that person's image is already there in the database, it's a match and it's an authorized access. So it will give you access to the building. If not, it will either trigger an alarm or it won't give you access to the building. So I have worked in both these companies, Honeywell and Johnson Controls. Honeywell, I worked in the aerospace sector, so nothing to do with this. But Johnson Controls, I was working on the building technology and solutions team, and where we basically did a lot of things like facial recognition-based access control, then like people counting. So how many at a given time, how many people are there? Then there were work around like social distancing measure. If at all, like based on the area of a place, if at all the density of people there is large or beyond a certain threshold, right? So there are lots and lots of applications that also like computer vision applications that basically are coming up in buildings that are getting deployed more and more in buildings, and facial recognition based attendance system or access control is one of them. One more project that I personally worked on is like you have CCTV cameras today, like if you go to office building or even your college building, except for few places where like privacy has to be basically respected, you have CCTV cameras. So now when you have the feed of the CCTV cameras coming to a central system, why waste that feed? You can use that feed to detect whether smoke or fire has been observed in any part of the building or not. So again, like computer vision based smoke or fire detection system is one big area today. Now coming to image segmentation, we spoke about like these are all part of object detection kind of thing. Solution, object detection, what we are trying to do is we are trying to tell where in the image a particular object of interest is and what that object of interest is. Now coming to image segmentation. So this has got a lot of application in medical imaging, right? So you have CT scan images, you have X-rays, you have MRIs, and you want the machine to basically assist a doctor. Why I use the word assist is a doctor can never be replaced. Machines are prone to errors. So it always needs to assist a doctor. And if you see like this image has been taken from NVIDIA's blog, and this is an outcome of their research. So if you see coming to axials, sagittal and coronal slices, what it is So these MRIs are three-dimensional in nature, and in three-dimensional space, you can basically cut a three-dimensional space using three planes: XY plane, YZ plane, and ZX plane. So these are basically when you cut that with XY plane and look at the cross section, YZ plane and look at the cross section, ZX plane and look at the cross section. So these three images correspond to that. Now, when I say that it is true, basically what it means is a doctor has been given this image and he has been asked to mark the areas, or a trained medical practitioner has been asked to mark the areas of where the tumor is present within the image. What this predicted thing is, machine has predicted, your computer vision algorithm has predicted that where in the image the tumor is, right? So you can see how well the machine has done when it comes to these three images. You can see, and you can basically slowly what these machine learning algorithms, as they are getting more powerful, there are times where it has been observed that it is even like surpassing human predictions. That accurate today, the state of the art in some of the applications is. So pretty interesting, and still like a lot of work to be done because it is basically opening lots and lots of opportunities as a day passes and people are trying to solve more difficult problems. Again, this was taken from NVIDIA, but Philips Healthcare, GE Healthcare, Google, and there are many startups which are venturing today in the medical imaging domain. So a lot of work is going on and a lot of exciting work is going on. This is just on the computer vision side, but based on like other ML techniques, there are like prognosis, diagnosis, so many things are happening. This is diagnosis, you're diagnosing and saying like if a tumor is present or not, but then like how will the tumor progress, like if there is a chance for it to become malignant or not, all those kind of predictions. Also, there is a lot of research going on those lines. Okay, fine. So till now, we covered face detection. We saw face detections like on our smartphones, we have face detection algorithms running. We saw face recognition. We saw face recognition based like unlocking systems that basically runs on your smartphones, on your laptops. We saw face recognition based access control, where once you enter a building, you just look at the camera, it clicks some pictures, it checks in its database whether you are already registered or authorized to enter the building. If it is, it grants you permission, it grants you access to the building. Otherwise, it does not. We saw computer vision based smoke and fire detection. Again, that comes under safety and fire safety. Then we saw one application in medical domain where like computer vision algorithms was able to tell you where in the image, where in the MRI scan the tumor is present. So we saw a lot of applications. Now again, like let us come back to smartphones, because I believe we relate to smartphones better and we use a lot of apps today. We all use smartphones. So let us come back to that again. And this time we'll look at a few of the apps. So I quit Facebook 3 years back. I deleted my account, but I'm not sure if this feature is still there, but I hope it is. So basically what it does is, as and when you keep on uploading more and more images of yourself or some person to Facebook, Facebook learns those features. There are some computer vision algorithms which are running in the background. What they are doing is they are basically detecting your face and coming up with a feature representation. So next time you upload an image and you forget to tag yourself or someone else, what it does is it is still able to suggest you that if you want to tag that person or if you want to tag yourself in some image. So this is Facebook's face tagging application. Again, with social media platforms, there comes one responsibility of, so they have terms and conditions of their usage. You are allowed to upload certain things, you are not allowed to upload certain things. And people basically misuse that, they violate the terms and conditions. So if I have to give an example, it can be like violent and sensitive content on the image or explicit content on the image. So detecting and flagging them automatically, if a human being has to sit and go through all the videos and all the images that are being uploaded to Facebook, it takes years, but machines can, like algorithms can always run in the background and detect and flag explicit contents. So this is again a part of responsible AI, and I think someone covered it in yesterday's session. So most of the social media platforms, they have these initiatives, they have these algorithms running which detect undesirable contents on their platform and try to flag them and bring them down from public notice. Now we'll move to Google Photos. Again, like Android users, I guess all of us have that as default application on our phone. So you might have seen, if you open Google Photos, you might have seen something like this. If you are a new user or if you have a new account created, these names don't pop like Oliver, James, Grace, Lauren. These names don't pop. Basically, what the algorithm does is it will group similar looking people together, and then it will ask you to add names. So this person, like I took this from public domain. So the person, whoever's phone snapshot this is, that person has given these names to the people who are similar looking and have been grouped together. So what this is doing is, it is basically detecting your face. It is coming up with some feature representation. So again, everything is powered by machine learning. It is coming up with some feature representation of the face, and it is trying to like, if the feature representation is close enough, it is trying to group them together. So if you click on James, you might have some 10, 15 photos or more of James. And like for each of those photos, when the algorithm like detected the face and computed the features lied very close to each other. So that's how they have been grouped together. So there are more like algorithms which are called like clustering analysis, which groups similar data together. So this is something like that. Okay. Again, I'm pretty sure most of us use Instagram. I'm not sure about Snapchat, but they come with this very I don't know if I have to call it cool, but yeah, these filters are getting very popular nowadays, and people use them every now and then. So you have this dog filter, which is basically replacing your nose with the nose of a dog and putting 2 ears. Here you have a filter which is basically putting some goggles, some fancy looking goggles on your eyes. What these algorithms are doing is, again, like first it is detecting where in the image your face is. And then once the face has been detected, it is doing some key point identification. So for this image of this girl on the left, the key points might be your nose, some points around your nose, and maybe on your forehead. And for this, the key points might be around your eyes. So once those are detected, it is able to place the object here in the right image. It is able to place the goggles just at the correct location, at the desired location. Again, Instagram, Snapchat. I have never used Snapchat, but I have used Instagram. So they have this explicit content detection algorithm, which kind of detects things that are undesirable on their platform and flags them. So you might have heard like many accounts being taken down. So these are because the algorithm has flagged the content as inappropriate for the platform, which is violating their terms and conditions. And for that, accounts are basically taken down as an action. Okay, so we covered pretty much a lot of computer vision applications till now. If there is any doubt, we can if there are any doubts, we can take 5 minutes to discuss them before we move on to natural language processing and automatic speech recognition.
Yes, students, you can ask if you have any doubt.
Okay, I assume
Yes.
we are good to go then. Or
Yeah.
like, is there any doubt?
No, Prantik, I think we can proceed with, and we can ask the students to ask any doubt at the end. Of the
Okay, sure.
session.
So till now we enabled the computers that can be your laptops, your smartphones, or any other machine to see using cameras and interpret what they are seeing using some computer vision algorithms that are running. So we move on to natural language processing or understanding. So what this field is. So I have taken a definition from the Wikipedia, but this field, again, like you have textual data and a lot of that. And if I have to read that textual data and come up with some meaningful representation of it, or like interpret what is there in the data or what that sentence conveys to us, that is the field of natural language processing. Again, like as with the computer vision algorithms, I'll take smartphones, apps from smartphones. To quote some examples from our daily life, we do use a lot of apps which are powered by algorithms, natural language processing algorithms. One is Twitter. Twitter has got this hate or abusive speech detection. So again, there's a social media platform where like anyone can go and tweet anything. And Twitter has got this machine learning algorithms which are running continuously. And as and when someone tweets something, basically it has to go through that algorithm. And if it passes the check, it appears, or many tweets basically are taken down by the platform automatically before they are seen by many users. So what this kind of algorithm is doing is it is reading the text of like whatever you are typing, whatever you are tweeting, it is reading it. It is kind of based on previous examples. So you train these models on lots and lots of text data that are both like abusive and normal tweets. So you train the algorithm on both kinds of data. And then based on previous experience, it is seeing that, okay, this is a new tweet. Can we flag that as a hate or abusive speech, hate or abusive tweet, or it is good to go for our platform? So likewise, it is flagged. And if it is being categorized as a hate or abusive tweet, it is taken down automatically before many users view that tweet. Okay, so while presenting the slides, these are the two images that I just used the Gmail app and the Gboard, and these are the two images I took from my phone itself. So you might have seen like both on your smartphone app as well as on the web app. When you type, like let's say a couple of words, it gives you suggestion. So this is from the web app. This is powered by the Gmail. Like this algorithm is running on the cloud somewhere, and you are being served through your app. Might be web app or so. See, when I typed hope this, it suggested me finds you well. This has been suggested by the platform itself, by Gmail itself. So this is again like a natural language processing engine is running. Again, here on your keyboard, like Gboard or any other keyboard on your smartphone, after I type this, it predicts 3 of the most like probable words, which might be the next word, and which the algorithm thinks might be the next word. So what this NLP engine does is it is trying to understand the context. Once you type hope this, in most of the emails you will write finds you well. So it is trying to understand the context, and it is coming up with some suggestion of what can be the next word. So it is again making life easier for you because you don't have to type this. You just have to tap it once and the text appears there. So these are again natural language processing powered algorithms that are running So when it comes to Gboard, a very small, very lightweight algorithm is running on your smartphone itself. And when it comes to Gmail, it's a much powerful algorithm that is running on the cloud. So we move on to again, like we move on to Gboard and Google Translate. So pretty sure you might have used this, like you type in some language. You also see this on Facebook apps, or Twitter also has got their translation engine. So you type in some regional language and it comes with the English representation of it. It is also present on your phone. I'm not sure if it is running, if the applications or the machine learning models are running on your phone or they are being served from the cloud. But yes, you have come across these kind of applications where you type in a particular language and you want the translation in some other language. And this kind of algorithms are becoming powerful day by day. And there are lots and lots of work also going on for this. And again, the objective is to make life easy for you. If you go to some place and you don't know you don't know the language that is spoken there, still you can use Google Translate to at least like help yourself out of difficult situations. Okay, so we covered computer vision, we briefly covered natural language processing. Okay, there are more applications to it when it comes to natural language processing. You give some reviews to let's say your favorite restaurants on platforms like Swiggy, Zomato. So basically, natural language processing works there as well for sentiment classification, sentiment analysis, whether that is a positive review or a negative review, and then flagging them like that. So if you want to read about all the positive reviews, you can go and just filter out the positive reviews which people have given. And basically, before taking a educated decision about whether to go for the restaurant or not, which might be a costly one. So before spending some bucks, you can take an educated decision whether it's worth spending for that restaurant or not. So these kind of NLP powered sentiment classification algorithms, they run on multiple platforms. Yeah, so NLP today is everywhere, basically everywhere. It is present everywhere. And I have tried to cover applications from your smartphone, so that most of the applications I have tried to cover from your smartphone, so that you get an idea of how much machine learning has entered into your daily lives. Okay, now having covered computer vision and natural language processing, we move on to one more very exciting topic, which is my current area of research and work, that is automatic speech recognition. So what is human speech recognition? I'm telling something, you are listening to it, you are interpreting it through your brain. So interpretation, again, like so interpretation and speech recognition are two different things when it comes to machines. So automatic speech recognition, what it does is it is converting what I am speaking to text. So it is coming up with the transcript. And natural language processing or understanding, which we covered in the previous section, basically comes up with meaningful representations or tries to interpret what is there in the text. So automatic speech recognition and NLP in many applications, they go hand in hand. Okay. So again, I'll take examples from our favorite smartphones. We have Googleboard. Googleboard has Gboard, and Gboard has got this voice to text application. So where you tap on the microphone and it starts listening to you. You speak. As you speak, it is automatically typing what you are speaking, and you can just tap on the send button over here to send the text. So again, making life easy. And you might have encountered these kind of applications at many places where like voice enabled typing is there. Most common application, again, I have quoted from your smartphones itself. Next comes voice assistants. And we have like Alexa, Siri, Google, now Google Duo, Cortana. So Cortana is from Microsoft, Alexa is from Amazon, Siri is from Apple, and again, this is from Google. So we have this kind of voice assistants. We know, like if you own an Alexa, you know what you can do with it, or like with Siri, what you can do. Basically, you can ask it to, you can command it, you can request it to play some songs, it does for you. So how this work is, when as you speak, the ASR engine, the automatic speech recognition engine, comes with a textual representation of what you are speaking. And then there is this natural language understanding models which are running and which are kind of extracting the meaningful representations from it. Like, let's say I tell Alexa, can you play the particular song from me, Summer of '69? And what Alexa does is, what the ASR engine will do is, it will convert that into text. And then from that, the NLP engine triggers, and then it says, okay, I have got a song request and the song is this, I need to play this. It will go fetch the song from the database and it will stream the song back to your device. So that is about voice assistants. I guess most of us know these are used in home automation. You can ask your Alexa to switch on, switch off your bedroom light, drawing room light. So again, like these kind of voice assistants are also coming up on vehicles. So there are a lot of work that is going on in this domain as well, automatic speech recognition. And so what I want to leave you guys with is, I want to show this video from Oro. So we covered, till now we covered computer vision, NLP and ASR. And this, like towards the end, I want to show this video because this entire thing that you see, this is an autonomous vehicle, the driverless vehicle, does not require any human intervention. And this was conceptualized and prototyped from my college, IIT Kharagpur. And they have, ever since like 2016, they have moved to the Silicon Valley and they have gained a lot of attention. So I want to show this video. It's a small 3-minute video. Let's enjoy it.
Hi, my name is Nalin Gupta, co-founder and CEO of Oro Robotics. We make self-driving shuttles. This vehicle I'm sitting in is the first prototype of our autonomous shuttle meant for transportation within campuses, such as a university campus, retirement community, and Disneyland type theme parks. We are currently doing a pilot in Santa Clara University in SF Bay area. Let me show you a quick video of it.
Just to interrupt, are you able to hear the music?
Yes, sir.
Okay, sure, I'll start. As you can see how well it navigated this and few of the obstacles.
This is no more a future fantasy. While bringing autonomous passenger cars on urban city roads might still be a few years away, we are already deploying such shuttles in the campuses. Since most of these campuses are private properties, we do not have to worry about government regulations, and they offer much more controlled environment to start with. The benefits of this technology are enormous. It reduces the operating cost by 40 to 60% in comparison to a manual-driven vehicle, implying a saving of more than $100,000 annually for every shuttle deployed in US and Europe. In addition, They can provide 24/7 on-demand mobility and can scale up the service in case of peak hours. A natural byproduct of ubiquitous shuttle service.
Okay, we'll skip the remaining part. So as you can see, this exciting thing has come up from India itself, and it was conceptualized in a college, and then they moved to Silicon Valley. Like if you go to their website, so in 2017, they were acquired by RightCell, and RightCell is a big player in this industry. If you go to their website, you can see there have been very positive reviews by MIT on this work, and Stanford also, if I remember correctly, has reviewed their work, and like they have got a lot of praise. So what I mean to say over here is, if you target the right set of problems to solve, there are lots and lots of opportunities, and you can start right from your college itself. So with that, I end my talk today. I'm open to questions.
Yeah, thank you so much, Prantik, for your really enlightening speech. And I would like to ask the student if they have any question, they can go ahead with the questions. Yes, please go ahead.
Excuse me, sir.
Yeah.
Sir, what are the prerequisites required to get started with computer vision?
Okay. So today, everything we are solving using machine learning and deep learning, to be very precise, you need a good understanding of mathematics. Okay. So I won't directly go into the domain knowledge. Like as you work, you can keep on gaining that. But main prerequisite into like machine learning powered computer vision algorithms is mathematics. You need to have really good understanding or decent understanding of mathematics. And like, even if I have to tell you very specific areas of mathematics, it's calculus, it's probability theory to a certain extent, and linear algebra. So these three areas, like any machine learning algorithm you take up, these three areas you should kind of know. And if you have to also understand classical computer vision, then you can, again, these three areas of mathematics is only going to help. And most of the algorithms from classical computer vision literature are based on these areas of mathematics. So yeah, I hope that answers your question. And again, like programming, because you should be able to code. So any programming language of your choice, C++ or Python, there is this OpenCV library. So they have got Python bindings as well. And deep learning based, there are multiple frameworks. So either Python or C++. Python is today the language of choice for fast prototyping. And when you deploy it, you might be writing your code in C++. Yeah.
Yeah, thank you, Prantik. We have another student, and please ask.
Yes, sir. Good morning, sir.
Good morning.
So when you were talking about finding out, I mean, like whenever you post any information on Instagram or any other social media site, it gets flagged and it shows that independent checkers have verified this information to be false. So like whenever you OCR any like image on the post, like how do they know like which misinformation are they targeting? Like is there any search optimization algorithm for that?
Sorry, after OCR, what you?
Yeah, whenever you OCR the text, and then like how do they know like they are targeting a specific misinformation platform? Like suppose they're spreading misinformation about COVID, for example. Like how do they know they're talking about like a specific point in that misinformation?
Okay, so there has to be some history to it. Like you need to have some patterns, like patterns which it has already encountered in the past, or like when the models were trained, it should have some similar patterns which it is saying in the correct data. Otherwise, there will be misclassification. So again, like how accurately it is flagging is a question and something which will keep on evolving, but there has to be some history to it. And by the way, these machine learning platforms or these algorithms which are running on your social media sites, there is a requirement of basically updating them very fast. So the engineers or scientists who are working on that, they keep on updating as and when they get new data. So does that answer your question?
Yes, sir. Okay, so anybody else is having any other doubt?
Good morning, sir. I have a question for you. Sir, at this moment, what exactly are the problems that Amazon is facing in ML and AI domain? Like, what problems are you trying to solve at this moment? What are the trends at your company?
So, so I can't say disclose this very specific set of things, but as I told, this kind of platforms goes through a lot of updates. So whenever there is a misclassification or a detection, we try to update our models. So that is again a data-driven approach, as well as we try to do research and come up with newer architectures or like a variation of the already existing architectures which might suit our problems well. So that is our research. Basically, whatever time we are putting to research, and so this is what like most of the teams in Amazon is doing. Again, you might know about Amazon they're coming up with counterless shopping experience, where you just go to the retail outlet, you pick up things, and you just show your palm. Your palm is mapped to your credit card, and the money gets automatically deducted. And whatever items you took as you were taking them out of the shelf, some camera captures that and it is putting it into your virtual cart. So there are the computer vision powered applications. This is heavily computer vision powered. So these kind of applications, this kind of problems also Amazon is trying to solve. And again, going to NLP, they have their shopping platform. So lots and lots of NLP based applications. Customer provides a review, whether it is a positive review, negative review. So those kind of applications also, like there are a lot of work going on.
Thank you. Yeah, thank you, Pratik. So anybody else is having any doubt, you can go ahead. Please.
Sir, can you hear me?
Yeah, I can.
Okay, so basically, what do you think are the basic aptitude-wise skills someone must require to make a career in ML? For example, logical reasoning and math skills is obviously an important thing, but at the same time, for example, a web developer, he needs creativity. And for someone who's doing a SDE roles, he needs some logical thinking. So in that respect, what are the core skills that a person must have in order to be successful in ML?
Mathematics, programming knowledge. You may be very good at it, or you might be decent at it. Mathematics is very important for understanding the algorithms, and even to train that to understand, like if it is failing, why it is failing. And second thing, you need to have a lot of patience, because you have to go through, you might encounter situations where you are seeing some failures and you have to go through the data and inspect and come up with basically figure out why your algorithms fail, because it is learning from whatever data it is seeing. So I will give a classic example. So in my previous organization, we had trained a model that was doing the smoke fire classification based on like whatever video feed was coming from the CCTV camera. And there was a lot of misclassification when it was night. So with all the illuminations, the lights are glowing brightly. It was detecting, like many frames, those scenarios, it was detecting as smoke or fire, or like sunrise, sunset. You have a CCTV camera mounted outside your building, and it is capturing some portion of the sun, and it is flagging that as fire. So what we have to do is we had to go through the data, figure out that, okay, in the negative class, so the positive class contains image of smoke and fire. in the negative class, we have not given enough images, or we don't have any images of like nighttime illumination or like the sun during the daytime. And as we had put those data, the model learned to differentiate between, okay, this is a sun versus this is a fire. So without that, because fire classification is very difficult, it does not have any distinct shape. It does have texture, but based on what is the source of the fire, the color also changes. You might have bright orange colored fires, you might have lemon yellow colored fires. If the source is like some kind of spirit or alcohol based substances ignited, you will have lemon yellow colored fire. So it is very hard to solve that smoke and fire detection problem when it comes to, again, like when we encounter the situation like illumination and this kind of like sun being misclassified. So again, like this is one example, but all the examples you need to go through the data, curate your data. Data preparation takes a lot of time. You need to have a lot of patience to it, and you should be able to gain insights from it. That comes with experience again. So yeah.
Yeah, thank you, Prantik. We have another question. Yeah.
Sir, one of the major AI problems that are yet to be tackled are ethics and morality. So how developers are going to tackle this problem in upcoming days?
Okay, so AI is again like it is a blessing, but it can be something that can be used for destructive purpose as well. And we can only hope that people don't use AI for destructive purposes, and only use it to come up with solutions that help and automate things and makes life easy for us. That is the only hope we can have. It again depends on ethics, is something which depends and varies from person to person. So as part of the developer community, we should be ethical enough to come up with algorithms which do not lead to destruction or do not harm anyone. So yeah, I mean, like, so all the social media platform as part of company initiatives, they do some work on these kind of domains, like they are, so you would have seen Instagram flagging some videos as sensitive content. So they may not want you to see, even like I spoke about Twitter, it is flagging and taking down tweets that are hateful or abusive. But again, like, you are always free to come up with your algorithm which is destructive. So it depends on person to person.
Thank you, Prantik. So anybody else is having any doubt, or we'll close the session? I think they don't have any other doubt. So thank you so much, Prantik. You have answered all the questions by the students in a very simpler way. And I hope the students got most of it. And thank you so much again for accepting our invitation.
Thank you.
Sorry, Prantik. One more question. One student is asking, so I think we should let them. Yeah.
Good morning, sir.
Good morning.
So like Alexa and Google Assistants there, whenever I say, hey Google, okay Google, it will start responding to me. So is it like the whole time my phone is listening to what I'm saying? If yes, then like it's isn't it a violation of my right to privacy?
Yeah. So very, very good question. It is not listening to you the entire time. Whenever you, so these are, you told hey Google or Alexa, right? Or Siri. So when you call out the names, these are called wake words. That is when the machine gets triggered to listen to you. So whatever you say after that is streamed to the server, not like it is not listening to you every time or recording things. So yeah, it is not violating your privacy in that aspect. But again, the terms and conditions is after you utter the wake word for the devices, they're going to listen and record whatever you are saying and send it to the server. Hope that answers your question.
Okay, sir. Thank you very much.
Yeah. Thank you so much, Prantik, again, and thank you for accepting our invitation and encouraging our students to join this in this field. So thank you so much.
Thank you so much. It's been a pleasure. Thanks for the opportunity.
Is it? So, good morning, Surya Roy sir. Are you there, sir?
Yeah, hi, I'm here.
Yeah.
Morning. Can you hear me?
Yes, sir. So good morning, everyone. So I'm glad to inform you that today we have a Dr. Surya Rai with us. So Dr. Surya Rai is currently a senior research director at Flipkart, where he has been responsible for AI, ML, data science, strategy, and execution of a number of key initiatives across a number of lines of businesses. Currently, he is leading the supply chain planning and forecasting technologies initiatives. Prior to joining Flipkart in 2020, he spent over 18 years in various roles in IBM Research and Xerox Research, as well as most recently was heading the AI labs at American Express. So Surya's technical expertise is broadly in AI ML and specifically in NLP, where he is well-known thought leader. He has been granted 30 plus patent, and his work has led to 80 plus publications with over 2,000 citations. So Surya is an ACM distinguished member and currently serve as the president of India chapter of ACM IKDD. Surya has done PhD, MTech, and BE all in computer science from IISc Bangalore, IIT Bombay, and Jadavpur University, respectively. Now, thank you very much, sir, for accepting our invitation. And now the session is over to you, sir.
Okay, great. Thank you. Thank you for the kind introduction. I hope I am audible to all of you. Yeah, my voice may not be at the best condition right now. I'm not at the best of my health for the last couple of days. So do let me know if you struggle hearing me. Let me share my screen. Can one of you confirm that you can see my slideshow?
Yes, sir.
Full screen? You can, right?
Yes.
Okay. Okay, let's get started. So firstly, thank you very much for inviting me. I see there is a room full of bright minds sitting there who are inquisitive, as I was told, to learn about AI and machine learning and how these are getting applied in different domains in the industry. So Professor Arun explained to me yesterday that the primary objective for the workshop is to share certain industry use cases to motivate the students. I think today's students are already quite motivated about AI and machine learning. I'll try to I'll add my views on top of it, especially from the domain that I'm coming from, especially the rich and growing domain of e-commerce. The way I have thought of this session is that so it's like 1 hour session. So of which half an hour to 35 minutes, I'll talk about e-commerce and at a very high level about e-commerce and how AI and machine learning is getting used in e-commerce in different parts, right? I'll try to double click in 1 or 2 areas, but it's quite broad, so I may not be able to kind of go to full justice. But what I would like to do is that I like to keep about 20-25 minutes to keep question answers by the students, and which could be about the topic that I'm covering, as well as about other topics such as career in machine learning. What do you need to do to get get into a career in machine learning in industry? What are the courses to take, or what are the skill set to acquire, or what are the best practices to follow? Some of those things, again, there are lots of material that are available on the web these days, but again, I can share my viewpoints on those things. Okay, so that's broadly is the plan. So now moving on. So starting from a bit about context about e-commerce. In this population, I would imagine that it is no news to you that e-commerce has become big in India and worldwide. There are newspaper articles of almost every day how e-commerce is growing, especially as an implication of this pandemic over the last 2-3 years. Festive season sales every year have been huge across all these e-commerce companies. And these companies have been kind of growing in terms of the amount of things, that the types of things they sell. Initially, many of these started selling only books 10 years ago. Today, they sell pretty much everything under the sun you can get in these companies. You don't go to any other place to look for. When you want to buy something, 2/3 of those product searches always start on an e-commerce web search, not on the e-commerce search, not on the web search engine. So they are the first points actually where people go and look for things, right? Initially, they started off by this. They had started by digitizing commerce, by taking offline to online, what that's called, right? Well, there is plenty to do still there. E-commerce is also inventing new way of doing commerce, such as social commerce, reseller commerce, quick commerce, and bridging the experience gap between the in-person shopping in offline shops as and when you want, to actually the convenience of getting things at a home and sitting at home. And all of these things they are doing by virtue of being electronic. They were born digital, and they built on the software and communication technologies. And secondly, they are always high on data. We'll see more about the data part in this talk and how those are getting used to build the next generation of the e-commerce using AI/ML on top of those data. Now, while the general growth in e-commerce is true, the growth story has been similar in India. But if we just take a perspective and how big it is to get a sense, e-commerce today in India, while has been growing, but is actually minuscule in compared to organized retail. So Bain and company, they conducted a study along with Flipkart, and it shows that currently e-commerce is less than 5% of the $810 billion retail market. So in spite of so much of growth, it is less than 5% today. However, there are big opportunities lies ahead, because India today has the third largest online shopper base of 140 million, but that is only less than a quarter of the total internet users in India, which is about 700 million, right? Hence, the projection is that the e-commerce market is going to grow from a very $30-40 billion today to $150 billion in 3 to 4 years from now. And as it is growing, you will see that more and more new use cases and new opportunities will come around data and building use cases on top of it. Now, moving on, how has, the other point that I was saying, that these data and technologies are going to be the 2 key enablers for growth of e-commerce platforms in the next decade and beyond. Now, again, kind of reinforcing the point that the e-commerce companies, if you read about the e-commerce companies, right, that how some of the largest companies have formed from scratch, you will see there are a few common criteria, the common pillars of success that are there, right? For example, customer obsession. So successful companies always from the day one have always talked about how obsessed they are about customer happiness, customer satisfaction, about using their service. Operation, how to set up efficient operation through the funnel of e-commerce, from pre-order to transactions to post-order. They're manically focused on that. Technology, most large e-commerce companies today, they have always realized early that technology is going to make them scale and win trust of people. Most of these companies, they saw themselves as technology companies and not as retailers in a way, right? And that is what has probably differentiated many of them from the rest of them. And finally, as I said, data. The data is, these companies have been extremely data-driven, or data-based decision-making has been core in their process. So as the scale and footprint of these companies have grown, they have expanded. As the scale and footprint of these companies have expanded, the volume and velocity of the generated data have also expanded many folds, right? And as you might have heard in many other contexts, that data is the oil. And indeed, on that oil, AI/ML machinery thrives. So first, let's see how big these data are. And I have some numbers from my company, Flipkart, a bit dated, but still it'll give you some idea about like what is the scale we are talking about. And then we will get into that. How is this data used in different parts of the e-commerce e-commerce value chain? So if you look at, right, and these are a bit dated numbers, but still representative. So a company like Flipkart has is like 300 million registered customer base, 200,000 sellers, more than 150 million products which are getting sold. Almost 100% of PIN codes of India are within reach of or have reach of Flipkart, so that actually the deliveries happen over there. 2.6 petabytes of data gets processed every day. And this 2.6 petabytes of data gets processed every day on a usual day. On special days, for example, as Flipkart has this known as Big Billion Days, when during the festive season, there is a major discounts and sales are given. And these are, there are much larger volume of data gets generated and processed, right? And these are some fun facts you can, I mean, these are taken to be taken with a pinch of salt, but basically this is the volume and velocity of the data that gets generated. Like, because now that you are selling 14 phones every second, 11,000 kg of almonds got sold in just 4 minutes. So it can tell you that not in normal BAU or business as usual day, but in festive season when such high volume of transactions goes on, how large volume of data kind of gets generated. Now, I hope by now you are convinced that there is a huge volume of data is getting generated in the large e-commerce companies, and as these companies are growing, they are also being able to kind of expanding their footprint of data in various dimensions, right? Now, once we know that, okay, that is data, but what's the big deal in terms of doing this kind of a transaction? So sometimes I have told, right, the general perception is that the e-commerce platform is somebody who buys from a seller and sell to a customer. I mean, they have a website, maybe an app these days, maybe some basic things like payment and delivery of stuff, etc. But what's the big deal in being connecting or being a connecting agent or a mediator, right? It's essentially a mediator, right? Connecting a bunch of sellers to a bunch of consumers. So it's not always apparent how technology, and specifically AI machine learning, plays a role in e-commerce organization. Yes, there is some search, some recommendation, but these are solved problems by the large-scale search engines. So what I will do is that I'll now just double click on that black box that you see at the center, and I'll show you what is the different parts of the e-commerce value system or e-commerce ecosystem, and that will make it apparent like where all AI machine learning plays a role. Right? And if there is one thing that you may want to take away from this presentation, I would say that this view is something that you would probably take away from this presentation. So what is the various parts of a hypothetical large e-commerce platform? So such a platform facilitates transaction between hundreds and thousands of sellers and hundreds and millions of customers. The sellers could range from large vendors to small and medium enterprises, to wholesalers, to direct to consumer brands. Similarly, consumers could be diverse depending on demography. They belong to kirana stores, to resellers, and so on. Inside the platform, there are some components which are consumer facing. What you see on the right of your screen, right? Like product search, product catalog, merchandising and advertisements, payments. Whereas some others, which are on the left side, are the primarily seller side modules. For example, management of product selection, quality, pricing, new seller onboarding, and so on and so forth. And of course, each of these are large software teams with possibly tens and hundreds of engineers, product managers, data scientists to work in these cases. And in some cases, these are companies by themselves. Now, there are a few parts of the platform which are relevant for both the seller and the consumer. For example, customer service. Trust, which refers to the detection and prevention of fraudulent users. So which strives to protect the genuine customers from fraudulent sellers, and similarly protect genuine sellers from fraudulent buyers. Acquisition and retention of new sellers and customers. Personalization and recommendation. So these are essentially modules which gets used both on the consumer side as well as on the seller side. Finally, there is a layer of central backbone, which essentially operationalizes the whole ecosystem. Foundationally, this is the supply chain, including inventory planning, demand and supply forecasting, accounting, which makes the movement of this possible. So each and every transaction that is happening in the e-commerce ecosystem is touching almost all parts of this ecosystem and leaving footprints in the form of data, creating opportunities for machine learning driven insights and solutions. And the volume and velocity of this data is huge. Now this diversity, now both the volume of data, which indicates the scale, and the diversity and breadth, which indicates the variety, is quite mind-boggling. So essentially, e-commerce offers AI and machine learning use cases on top of large data sets over each of these boxes that you can see. So today, you can think of that in an e-commerce company under the common umbrella, there may be 5 or 6 different industries are there, which are operating on different machine learning problem statements, and of course, which is fueled by this live volume of data. Okay, I can take a pause for a minute if there is any pressing question.
So do you have any questions? You may come forward. I think, sir, no questions. You may continue.
Okay, fine, that's fine. Okay, so what I will do, I thought that I'll, yeah, maybe let's see. Okay, so I thought that so basically each, as I was telling, like each of these boxes have myriads of machine learning AI problems underneath. So I thought that I'll double click on a few of these areas, at least 2 or 3 of these areas. And I thought that forecasting and pricing are the 2 areas in which I have recently done some work. So I'm more kind of I can talk about some of those. Trust is another one, but there are many, almost in absolutely now across all the dimensions there are many interesting problem statements. And for each of the other points, I'll give that, okay, what is the context and how the opportunities and challenges are there in AI machine learning, and then samples of some of the state-of-the-art research that are there. And finally, as I said, that extended Q&A about any part of this talk or any other topic that I have. Okay, so forecasting and planning. So forecasting is, what is the problem? So forecasting, the basic problem is that to predict demand of products, that is, which products will sell, how much, when, and where. Now, why do we need it? So that the company can stock the right products in the right quantity at the right place and at the right time. Essentially, this is a very old fundamental problem by any retailer. Now, and then e-commerce, if they can predict this demand, consumer demand well, consumers will always get that product they are looking for. And if their product predict well, then the sellers will also know that, okay, what they have to give to the company. So essentially, right forecasting enables the e-commerce to do the best and most efficient matchmaking between consumer demand and seller supply. Why this is complex, especially in the case of, why this is complex? There are several nuances to this, this particular problem. Firstly, very large selection on the number of products these companies sell. As I told you earlier, like 150 million products are getting sold, right? Hence, forecasting systems needs to handle this large scale and variety of products. It's not about 10, 20, 100, 200 products. It is about millions of and hundreds of millions of products for which forecasting need to happen. Secondly, the demand time series, the products are inherently non-stationary and thus violating some of the core assumptions of the classical methods. So historical patterns can be leveraged to make decisions on inventory levels for some products with predictable consumption pattern. For example, household staples. However, most products exhibit a variability in the demand due to factors such as fashion trend, some external event, and so on and so forth. And additionally, demand of products are often interrelated due to complementarity or similar offerings from various other sellers and brands, etc. Thirdly, large e-commerce companies need to forecast at different granularities of time for next week, month, quarter, or even for a year for different business planning exercises. Similarly, for geography, country, zone, and essentially able to predict the finest granularity of geography. So it is essential to predict the overall demand for the one product at the whole country level, but also for different brands and sizes and different types and different models at different parts of the city. And finally, many other e-commerce specific nuances, sellers competing for offer similar products, new seller or products arriving at the platform, unplanned sales and discounts. So there are so many dynamic behavior are present in e-commerce setting that predicting or forecasting for actual demand becomes extremely difficult. Now, one interesting good thing about forecasting techniques was that the culture and practice of open data sets and shared evaluation have been existing for many years. Many of the students here may be knowing about this competition platform called Kaggle, which made actually many of the open source machine learning data competitions very, very popular in the last 10 years or so. But forecasting competitions have a longer history when this competition called Makri-Dakis competition or the M competition series, which was started around in the early 80s and has held many editions to actually shape up the way forecasting research and forecasting domain has kind of evolved. Similarly, there is a very, very interesting blog post that I was reading from Amazon Science some time back, which actually talked about that how forecasting technology has evolved. For example, about 15, 20 years ago, time series based forecasting techniques were the most popular ones. They were good, but only when these time series underlined are the predictable and stationary, but not the realistic situations such as the new products and so on and so forth. So then came the era of what is known as the auxiliary models, where additional models to deal with seasonal patterns, price change, etc. were introduced, leading to many models which require domain expertise to decide which one to use when. Then came the era of the unified models or the random forest-based techniques, where based on the intuition that the products across multiple categories that behave the same way. For example, every new mobile phone does not require a new forecasting model. So random forest models trained on a set of new features, information on demand, sales, product category, page views are important. But it still had a drawback that it required extensive and tedious manual feature engineering, and which need to be overcome. So finally, then came the era of the neural networks trained with customized loss function and so on and so forth. So today you will see that the state of the art research is techniques are primarily around deep learning, ensemble of trees, as well as traditional time series, depending on the setting data one can choose. So here are a couple of examples of the samples of some of the recent research. One of the papers that got published last year was on the premise that looking into related time series may be useful during prediction. For example, it might be beneficial to look at out of stock status for the same product from other sellers, or launch of competing or other similar products, price increase and decrease of other sellers offering the same product. So basically, this work proposed a new method for predicting product demand that factors in correlation with other sellers and products. So this is fundamentally different from when a time series techniques actually looks at only the product sale of the past, but actually now it looked at the sales of the product from the other similar products and so on and so forth. And so they use time series technique on top of graph neural network and LSTM, long short-term memory, followed by a final layer of multi-layer perceptron. Again, I understand some of these terminologies might not be very familiar to you, but at the same time, I know many of the young students these days are quite active in terms of advanced studies of their machine learning and deep learning. So sometimes it may be familiar. So do not worry, even if you do not follow each of these terminologies accurately. But essentially, the idea is that certain specializations of neural networks and deep learning were used with very strong, solid business and product intuition to arrive at forecasting by overcoming the shortfall of the traditional time series based forecasting. Similarly, the other early paper, one of the early papers from Flipkart, which proposed another neural network architecture for predicting demand through identification of a number of what they call as the causal features and the combination of feature embeddings using, again, multilayer perceptron and LSTM to represent them. And features of different types of product, visibility, price, convenience, time, etc., which were combined to arrive at the combined joint loss function over as a to predict the probability distribution as a mixture of Gaussians. So instead of doing a point forecast of a product, so it was giving a distribution or a probability distribution of a demand for the for each of the products through this model. So let me skip this slide just for the time. This second problem I wanted to mention about is the pricing. So one of the core problem in the e-commerce platform is to identify pricing suggestions for sellers. So sellers often have the flexibility with respect to how they can price a product, and they would like to do it in a manner so that their products sell more, giving them more business and overall increasing their profitability. But they don't know what is the right price. Now, the idea is that a platform having able to access to across multiple, a large volume of product and large volume of transaction, can they identify what is the right price suggestion? And what do I mean by right price suggestion? A price suggestion which increases the profitability of sellers and the platform while providing the best price to the consumers. Now, this is tough because their sellers can sell just about anything, and the product base is in, again, hundreds of millions. So on one hand, pricing depends on a number of factors. On the other hand, only difference of one attribute, for example, brand, can change the pricing of a product significantly. Secondly, price varies due to external factors such as sales, promotional events, and so on and so forth. So there are multiple reasons because of which these pricing can vary. And finally, often pricing data is not very reliable every time. So inadequate, incomplete, and poor quality of data kind of creates additional challenges to arrive at the right pricing. So couple of examples of techniques, how some of these large e-commerce companies have started addressing the pricing problem. So in Alibaba, they proposed a multimodal price suggestion system, which takes as input visual and textual features of product, along with some of the statistical item features, collected from their second-hand item shopping platform. Now, this is a two-step technique. First, they evaluate whether the features that are present in terms of image and text of an uploaded item are sufficient for reasonable price suggestion. For example, if there is not sufficient data, then you may not actually have the confidence to be able to predict the price. So first they do this as a binary classification model. And next, they provide price suggestion for those items with a regression model. Now to satisfy and again, on top of it, they put additional layer to satisfy different demands. 2 different constraints are added into the joint training of the classification model and regression model. A customized loss function is added, which can not only maximize the gain of the sellers, but also facilitate the online transaction. But basic intuition here is that based on the visual and the textual features that are provided with the description of the product, can you predict the price of a product? Similarly, this another work from Myntra, they use the notion of price elasticity demand in a 3-stage approach. So firstly, they use a demand prediction model to predict the next day's demand for each product at a certain discount percentage. Next step, they use the concept of this price elasticity of demand to get the multiple demand values by varying the discount percentage. So you compute the demand, then use the demand price elasticity to see that how the demand will actually fluctuate. And then finally, you can arrive at, and through that, you can arrive at multiple permutations of price point and the quantity of each of these product that will sell at that time, which will then sum up to a unique revenue number. And given these products are interdependent, increasing demand in one product may actually affect the demand of the other product. Eventually, they choose the best permutation, which gives the maximum revenue, and towards that, they employ a linear programming-based optimization technique. Okay. Finally, let me come to my final set of examples. This is from the trust domain. Again, the reason I have chosen some of these examples, because these are often less studied or less talked about compared to some of the other ones, for example, more like natural language processing or search or so on, which are more commonly you guys might have heard. But through this talk, I also wanted students to be aware that AI/ML is not only used only at the surface form, at the text and image, but actually throughout the e-commerce ecosystem, and make you aware that, okay, how broad and deep this area is. Now, the final example that I was talking about is that one of the biggest inhibitor for the digital commerce or e-commerce getting adopted in any country, and especially in countries like India, is that the lack of trust. It is kind of psychologically, socially, or maybe by the way that we are born and raised, it is very difficult to trust somebody whom we have not seen and make a transaction. Of course, things have changed a lot in the last 10, 15, 20 years, and we have become much more comfortable in doing transactions remotely. Electronic transactions have become extremely secure, and so on and so forth. But that probably does a lot has caused a lot of penetration of e-commerce in general and helped in that. But still, there are 2 aspects which still kind of contributes to the lack of trust in e-commerce, namely fraud and abuse. So fraud refers to essentially explicit activity which is undertaken by an entity in an e-commerce or any financial transaction that leads to unwarranted monetary gain of one party at the expense of another party. For example, a card is stolen, a product is missed, some product is getting stolen from the supply chain, and so on and so forth. There is another kind of wrong activity, which is known as the abuse. So abuse is defined as the repeated behavior by an entity on the platform that is statistically outside the fair usage. Now, abuse does not directly lead to the monetary gain of the abuser, but accrues monetary loss to the other entities. For example, and one of the very, very common abuse example is that excessive return. So today, e-commerce companies often give, for customer satisfaction or customer adoption or increasing trust, they give this free return within a particular time period for many or most of the products, right? It has been observed that a particular set of a particular group of customers or certain segments of customers, they do abuse by giving excessive return to the customer. Now, one may ask that what is wrong, because the company is offering the ability to give returns, right, or return a product, right, without any monetary loss for the customer. The challenge is that if I am an abuser and I buy 10 instances of a product and I return 9 of them eventually, then those 9 products get stuck with me or for me in the supply chain, both while coming to me as well as from going back to me, maybe for 2 + 4 or 5 days or 7 days or so on and so forth. And during this period, nobody else can actually order those 9 items, right? And essentially, I am actually abusing the supply chain and the product repository of that. So in essence, so there are these kinds of behaviors are not desired by e-commerce platform, and hence the ensuring trust and prevention of fraud is essentially one of the key areas that technology-based solutions are needed. And this is where, again, data-based or AI and machine learning-based solutions are extremely critical as these are being done. So why this is complex? Because this nature of fraud and abuse is continuously evolving. The scale and diversity of data is lack of sacrosanct labels is always a concern. It is always difficult to tell whether something is an abuse or something is a fraud. It's not always, but quite a few times it is quite difficult to tell whether certain behavior is indeed an abuse or not. And finally is the walking on the thin ice of decision making, which essentially mean even if I know with like whatever 80% confidence that a customer is actually abusing the platform, unless I am fully sure, it is difficult to take an action against the customer, because if by chance if the customer is not an abuser, then he or she will probably never come back to my platform. Again, there are a bunch of work that has happened in this field. So for example, again, this work from Alibaba, which employ these techniques called graph-based fraud detection approaches to leverage the relational information of detection of detection of fraudsters. So the nodes are the users and edges are different relations. And relations could depict anything from like 2 users reviewing the same product on the same day. That could be one relation. 2 users buying the same product on the same day could be one relation, and so on. And they employ what they call as a node sampling or a label propagation technique, followed by this graph neural network based embedding and prediction for unseen fraud and benign holes. And in particular, they claim to address what is known as this imbalanced class problem, which is very common in this fraud detection, because fraud class is always a very small class versus the non-fraud or the benign class. The other work, which is I'm shown as an example, is about detecting and identification of fake reviews of ratings. So this is another kind of abuse of the platform. So I can always go and give a fake review or a false review or a false rating on the platform. Unless it is detected and prevented through a mechanism, as maybe by profiling the user, maybe by connecting my purchase history, or maybe by connecting the with the rest of the users' ratings and so on and so forth, it is often not possible to decide on the what is the fairness of a user, how is reliable is a rating, and what is the goodness of the product in the context of detecting fraudulent reviews, right? So this is like all of these are intertwined, like how fair a user is, how reliable is his or her rating, and how is the inherent goodness of the product of a product. All of these are kind of very highly intertwined. And again, kind of going back to the scale point, that doing this at the very, very large scale of e-commerce and the number of ratings and reviews that are coming to these systems, it is absolutely important that we will be able to do this from the data and through use of these machine learning techniques overall. So with that, I'll come to and the stop here. But at this stop, while stopping, I will again flash this particular screen, the picture that I had showed earlier, and essentially tell you that the story is that e-commerce is poised for big or bigger growth in the coming years, with data and technology playing a strong enabling roles. This domain is rich in data and richer in problem statements. I gave you very, very whatever tip of the iceberg kind of problem statements, some samples in some of the unusual, less known areas. Advancements in various subfields of AI, machine learning, data science have made significant breakthroughs, and more are going to come in the coming years. Okay, so with that, I'll stop here, and I will be very happy to answer any question, anything that you may have, both from the topic that I covered, as well as any other thing related to career and any other question you may have.
Thank you, sir. Thank you for such a wonderful talk. So now I request students, if you have any question, please come forward.
Good morning, sir. As you told that the fashion trends and some factors can increase the demand, so the ML models at Flipkart, do they take this in consideration while giving you the result, or does it happen manually? And if it happens with ML model, then how does that ML model works? Like how they take that input in consideration and give you a result, and without affecting the normal results?
Sure. Okay. One request, student, when you are asking the question, please tell your name and maybe your grade and which stream you are in. I would appreciate that.
Yes, sir. My name is Shreyas Kasliwal, and I'm from like Triple IT Shri City.
Okay, Shreyas. Yeah. So Shreyas, no, that's a very good question. Again, I mean, I know that you are asking the question in the context of Flipkart. I will not be answering the question with respect to Flipkart, but I will be answering the questions in a little bit generic. Yes, any kinds of demand that happens, that demand prediction or demand forecasting that happens, there are multiple sources of signal that comes into play. One is, of course, about that how the past has been in terms of what has been the sales, what has been the demand at different parts of the country or different part of the city has been here, right? But on top of it, there are many other things that comes in, right? For example, this fashion, in particular for the fashion segment, like what are the newest trends? What are the latest fad and latest seasonality that is kind of going on with respect to fashion products, right? Yes, some of these data are actually incorporated on top of the forecasting models that are there. How automated these are depends on how mature is these signals are. See, some of these signals are often kind of ad hoc and kind of known as more of maybe coming from an influencer on Instagram, or maybe based on from a particular movie that has come up, or maybe in a particular geography, there are certainly some kinds of common trends that are being seen, right? So while these, to answer your question, while these signals and about trends and external data is taken into account, some part of it is done systematically through data, through machine learning model. Some part of it could be actually based on rules, or maybe based on domain knowledge or business knowledge, which goes on top of the model-based predictions. I hope it answers the question.
So is there any other question?
Yes, sir. Thank you.
Please come forward.
Any question? Any question? General question. Some of you come forward. Ask question. Some of you. No one needs to think about it. Come and ask question. For your benefit.
So I have a one question, sir. So am I audible, sir?
Yeah.
So being a senior research director, sir, so what would you advise to our student? So they should have a good programming skill, or they should have a like good innovative mind, like they should focus more on the research area. So what would you advise?
Yeah, I mean, both are needed. It is not one versus the other, in my opinion. So again, I mean, if I look at like a 4-year or 5-year, like an engineering, or often like this dual degrees 5-year program. So first couple of early years, in my opinion, you should get very strong fundamentals, get your basics right, the students, like things like algorithms, data structure, programming, on the computer science side. Similarly, on the math side, getting very strong foundations on probability and statistics, calculus, linear algebra, optimization. So those are the very, very fundamental core subjects that you should get expertise on. 3rd year onwards, do elective. 2nd year, 3rd year, again, depending on when your courses permit or curriculum permits, do electives on machine learning and related topics, pattern recognition, statistical modeling and uncertainty, analytics, visualization, NLP, computer vision, signal processing. So as many electives or as many core subjects you may have, depending on your program, do those. During the 3rd year and 4th year, you also, as much as if you can do, if there are opportunities for you to do projects like course projects, maybe if you are taking your BTech projects, if you're truly interested in machine learning, do definitely make sure you do a project in that area. Data challenge such as Kaggle is a good way to dip your toes to do some real life projects in that. And so, for example, platforms like Kaggle gives you a lot of opportunities in that. Do internship again if your program permits. Do internships at maybe at the industry, maybe at other academic institutes as and when you are there. In fact, I would like to kind of mention this to you that so I currently run the SIGKDD India chapter. I'm just the current president of that SIGKDD India chapter, known as IKDD. And we launched a new program called Uplink this year. For this year, this edition is over or rather application period is over, but where actually we have introduced an internship opportunities with some of the top researchers in top colleges in India for students in the pre-final and final year from various other colleges and institutes, right? So in general, I'm trying to tell is that this is just one example, but any internship opportunities that you may can avail after your second year, after your third year, do avail those because that gives you very, very practical exposure to and broadening your horizon in the way. So again, recap, start your fundamentals with programming, maths, go into do core subjects in machine learning, pattern recognition, natural language processing, so on. End with doing good number of projects, practical data challenge, internships, and so on.
Yeah, sir, we have one more question. So,
good morning, sir. This is Naman from UG2, sir. So, sir, I wanted to ask, like, to do internship, like in Flipkart only in AI/ML field. So, what is it expected from a UG2 like student if I want an internship? What is the
yeah? Go ahead.
Yeah, what is the skill set required, and like, what do you expect from a candidate?
Yes, I mean it's very hard to tell. Because this is that only is the list of skill set that is there. So let me give you a laundry list of things. Okay, so strong foundation of computer science like data structure, algorithms, programming, logic. These are definitely are essentially what should I say is like must have. Being able to do machine learning formulation when given a problem. So I give you a problem. How are you able to formulate that problem into a machine learning, classical machine learning formulation, or whatever, not forget classical machine learning formulation, and do the right modeling on top of it, do the right experimentation framework. Can you come up with what are the right metric, and so on and so forth, right? So these are the two main aspects in terms of that very strong foundation and ability to actually take up a problem which is relevant for a machine learning formulation and being able to do that and solve it. The third aspect is a bit more generic, is about how familiar you are in general about existing tools and technologies, open source implementations, strong familiarity with packages, data handling, scalable computing, big data systems, and so on and so forth. So some of these are very practical. It's not probably anywhere taught as such, but these are more comes from by your hands-on experience, hands-on practice, by participating in challenges, by developing your own maybe projects, and so on and so forth, right? So that's broadly. And finally, I mean, as an individually, when I look for an intern or a student, one characteristics that I look for is that what I call as the fire in the belly. Fire in the belly essentially refer to that there's always the hunger and the keenness to learn continuously, adapt, gather domain knowledge, try out new things. So those are some of the things. And again, you may ask, okay, how do I look for that? Well, that's what is essentially when I talk to somebody, and that is the time I try to gather how hungry that person is to do a project or an internship or a job.
yeah, so we will take one more question, sir.
So my name is Sai Kirtana. I'm an MTech student. I'm doing it in AI/ML. So my question is, so we discussed about product recommendations. So I wanted to know how federated are these machine learning models? If not, how soon can we expect such models in the field?
Sorry, I could not hear you. Can you please explain your question a bit more?
So I wanted to ask how federated are these machine learning models regarding some product recommendation? These models are doing some product recommendations for users, right?
Yes. When you say federated, could you please explain what did you mean by that?
Yes, sir. How decentralized are these models? Is my recommendations is like what I search and what I look for is something that is the data is confined to me, and how?
Okay.
Certainly.
Sure. See, the recommendation that comes to you, that is definitely personalized for you. But the learning mechanism that is there, that is learning on top of all or whatever large segments of user product interactions, so that I am able to leverage the power of large volume of data or large volume of user product interactions to come up with recommendations which are most relevant for individuals. Right? Only when I'm able to churn or only when I'm able to massage this large volume of product and user interaction data, then only I will be able to kind of generate that, okay, what else could be relevant for you based on similar users or similar products which other users might have seen. So in nutshell, your recommendations are personalized for you, but these personalized recommendations come from churning a large collection level data of a large number of users.
So I think no more questions, sir. So once again, I would like to say thank you for giving such wonderful talk and motivating our student. So I hope student might have gained a lot from your talk. So thank you, sir, for accepting our invitation in short period of time. Thank you once again.
Yep. Thank you very much. I thoroughly enjoyed it. Thank you.
Thank you. Thank you, sir.
Yeah, the next speaker with us is Dr. Gandhi Sivakumar. So Dr. Gandhi Sivakumar is a distinguished engineer at IBM. She is an open group distinguished certified information architect, transforming IT organizations towards state-of-the-art artificial intelligence technologies enabled through core innovation. She has filed more than 240 patents and have many IEEE publications. She continues to co-chair many IEEE conferences and have published a book on common information models. She served as a board member of Australian Computer Society between 2012 to 2013. She was honored with multiple internal and external awards for innovation. It's our pleasure to have you here, ma'am. So you can kindly proceed with your talk.
Hi, everyone. I need to see you waving your hands. Students, excited? Good. So I'm going to share my screen. I am seeing disabled. The screen is disabled. Can I request the organizers to?
Yes, ma'am. We are just making you the co-host so that you can do it. Yeah, you can try now, ma'am.
Still, it has not come through. Multiple participants can. One participant. When I click on that, it shows share. When I click on the share screen, it says one participant can share at a time. I don't know. It doesn't give the option to share.
Okay, ma'am. We are just checking. What?
Ma'am, can you try once again?
Yeah. So when I click on it, it says one participant can share at a time. So when I click on that one, it does not show anything, right? So it should show me that share option. So the other thing is I can actually email this to Dr. Arun or somebody, and then you can as well project the screen if that's okay with you.
Yes, ma'am. We are just again making you, removing your permission and again making you co-host. Yeah, I hope this will work this time.
Should I log out and join again? If not, sorry, we have 2 more minutes to start the session. I'm so sorry, students, about this logistics. Give us. Yeah, got it.
Hello.
Able to see my screen?
Yes, ma'am.
Okay, students and all the leaders and the director. Sorry. A very good afternoon to you, and thank you so much for taking the time to actually join this. Sorry, I heard a noise.
Yes.
Yeah.
So, sir, if you want to say something, please say. Ma'am, please wait for it.
Oh, yeah, sure. Sure.
Sir. To say something.
Stop the screen.
No, I close it. Yes, ma'am, you can go ahead, please.
Okay, thank you very much. Students, good morning again, and thank you so much for taking your time on a Saturday to be a part of this session. I'm going to actually talk to you about, aligning your technical strength with industry trends. I'm going to also give you, so let me go to the next chart and then I'll show you what is the agenda I have. Yeah. So the agenda I have for you today is I'll talk about my career journey of 31 years in the industry since I finished my undergraduation. And you will also be wondering why I wanted to talk to you about it, but there is a motivation behind that. I'll share with you shortly. Then I'll talk to you about the trends in the AI and with use case references and so on. I'll try to make it as easy as possible for you to gulp. Right. And then I will also touch upon specific career opportunities and also the skill sets you need. And you did hear I just happened to join Dr. Shaurya's session now, and there as well, he touched upon a lot on this, but I'll be reiterating on that. And then we will open the forum for question and answers. Okay. Now, what I want to request you is to actually take a pen and paper and actually have a question, at least one question, each of you. And I know that the time is very short. If I'm not able to answer your questions in the session, I will certainly, request you to actually, email it to me via Dr. Arun or whomever he nominates, and I will ensure that I respond to you each one of your questions. Okay, excited? I always have a problem in navigating to the chart. Okay, my journey. I finished my undergraduation in 1990 in REC, Trichy, NIT, and I was also honored to actually kind of the same institute where the director, Professor Kannabiran, is from. So it was very exciting to see that, when I saw a note from him as well when I was asked to actually speak in the session. But to tell you that, right from the school days, I have been always doing very well in my career and it might sound funny, but when I turn back and look, I started to explore my areas of interest even when I was in grade 2. You won't believe that, but it's a reality. When all the other students used to actually play in the mud and sand I'm originally from India, obviously, but settled in Australia here with core value systems inherited from there, right? So, but I used to do all the scientific experiments and then start to actually play my this thing. When I turn back and look now, I just thought that somehow I inherited that. Anyway, I really wanted to also set the context to tell that I'm not here to market myself, but what you're going to learn in this journey is key thing is alignment. How did I align myself with what the industry trends were, and as well align with what your employer is looking for, and especially what your business unit is going to look for as you start to transition your journey from the university to work for an employer, right? And obviously self-eminence. So this is one another thing, as especially, I think from the culture of India, we don't actually kind of go and market much about ourselves. We expect others to actually know more about us, but certainly it does not work. The industry does not work that way. So you have to actually tell what you are good at and what your accomplishments are. It's not that specifically you go and tell, even in a conversation of meeting your executive or manager or whomever you interact in the business, don't feel shy to talk about your achievements, because you should be very proud of it. And that is exactly what the industry expects, right? So that is a cultural change I really wanted to as well bring through. As I said, there is a motivation for me to talk on this journey. And yeah, so I did my VCE in REC, the present NIT Trichy, and then started through the campus interview in a Government of India telecom company. And there as well, all the time, I was blessed to initially I started in the research center, and then I moved to engineering, where we used to develop, exchanges, the digital exchanges, telephone exchanges, and always in the creamy layer, as a top performer. And then that was the time, at least first 12 years of my career was, I had to actually build my family and, settle my sons in terms of, going to school and so on. But after that, I felt that I have to start continue my career in terms of, higher studies. So that is how, I figured out a balanced one where I could work at the same time as well, go and study. And BITS Pilani is where I went and registered my master's. So initially I did believe that, it's going to be really hard for me, mother of 2 children, and getting into the world of industry. How am I going to actually excel in my studies and so on? But believe me, after like 4 weeks or 5 weeks, the brain started to actually revamp, and then in fact the understanding and other things were even better than I was a student, right? So that is how I did excel very well with 9.1 CGPA in masters. So the key thing is, here I wanted to mention that your age, your stage, and especially if you are a woman as well. I don't want to have a gender bias here, but certainly being a man or woman, none of your stages are going to actually impact you or be a hurdle to your progress in your studies, education. Continuous education is very, very important. But then after, I did work in IIT Research Lab for a while, and then I kind of moved to IBM. In IBM, again, my passion was all the time to, I initially joined IBM India in the software group in Bangalore. But then again, I wanted to actually do my PhD, and then went in search of universities through, again, IIITB Bangalore is one place IBM had a lot of tie-ups. But then eventually my mentor said, if you want to grow in IBM, you have to actually kind of go and do certifications, right? And you should have handled massive projects. And that is how I landed up into actually a big project here in Australia for a major tier 1 telecom industry here. And there, that was a time, this technology, what you see here, right? It's a service-oriented architecture technology was there. And I tried to actually apply the common information model, right? Information model is a very complex stuff, and tried to apply these two together and came up with n number of innovations there. And in order to protect IBM's IP and also take credit for my innovation, I actually churned a lot of patents in this area. Then in this time period, I also got certified in IBM. There are multiple levels, right? I am dually certified, which is also IBM certification with open group certification, which is for information architecture. And then in the journey in 2015, I also got certified for data scientist too. But anyway, this was all first of a kind programs and overseas projects and so on. So what I ensured, and which I really wanted to share with you students, is any opportunity which your leaders come up with, right? Don't ever say no. All the time, feel free to actually be open. You never know which opportunity is going to actually take you up and grow and realize your dreams, right? And fulfill your dreams. So always be open to whatever responsibility is given to you. And also, as a leader, when you grow, you will not like somebody telling, no, I don't want to do this. Don't be choosy, right? At the same time, as I said, right, it might actually open up a lot of opportunities and create a very good name for you. And that's exactly every relationship I maintain with the team or my seniors. I ensure that the relationship is valuable, and I am always of valuable to everybody. So that's exactly you as well wanted to practice in your journey after you step up, and even now you can do that. Then I actually again progressed to become IBM Master Inventor. That is a credential IBM gives as a pride for inventors, and there are other things as well. We groom multiple other inventors and so many programs within IBM and so on. So that took me to become a Master Inventor, and then also built up my technical eminence. I served in the Australian Computer Society board as an external board member, and then multiple awards. One of the biggest awards I got was ideally within the country, it was the Australian Retail Net Award for Innovation, and similarly a global award for STEM. And my company sent me to US to actually receive this award. So that's something I thought I should be very proud about. Obviously, I'm a very strong, follower of Lord Krishna. So I'm thankful to him for helping me out in this journey. Is what I wanted to touch upon. But then, as time lapsed, right, what you can see is the technology keeps changing. So initially I said it is SOA, right? And then service-oriented architecture, then came the business process modeler and so on. And then the industry shifted towards cloud-based offering. 2009 timeframe onwards, people were starting to explore and so on. So though I did not know what cloud was and I was not actually exposed to any of the projects, I used to learn myself. And then in fact, RMIT University here actually invited me for giving 2 talks on cloud computing even then, because though I was not aware. So the ability for you to update yourself on the latest trends and technologies in the industry. I'm hearing a lot of noise. Thank you. So, so ability for you to actually be aligned with where the industry is going is very, very important, is what I wanted to actually give one another. Maybe I might repeat it again and again, but that is to actually infuse this into your bloodstream. Okay. And 2015, when actually the industry started to trend into AI by big data and so on, right? So my business wanted to pick me up, and then they actually asked me to front end a number of complex projects in the AI, and there as well I learned a lot. It was a deep learning curve for me to actually learn multiple things, because in AI you have multiple things. I'm going to talk to you about in the next chart. You will appreciate. And if you have any questions, as I said, right, just at least I expect you to ask one question, pen it out. And so I was asked to actually spearhead very complex projects and came up with a lot of innovations, and I got certified as a data scientist as well. And externally, when you are really good externally as well, people will start pulling you up and so on, pulling you into their initiatives and so on. So I served the Australia standards as a core committee member for 4 years, but now because of the bandwidth reasons, I actually opted to stay off as well. But last year, I actually was nominated as a distinguished engineer of IBM, which is one of the biggest this thing in recognition in IBM, and it's an honorable recognition as well. So just like it's climbing Mount Everest, it's a journey, right? Step by step and so on. So that's where I'm now. I lead the development portfolio of IBM of number of products, and yeah, so that's a very quick journey. And in line with this, I also went and registered my PhD in 2017. And again, I was blessed that my earlier attempts, 2 times I attempted, but for some reason I could not actually do it. But eventually I thought it was for good, because I'm now into AI, and AI technology is going to be the future, and in the industry for more than 30, 40 years. It's going to evolve, but it's going to be the future. Okay. Let's go to the next chart. I'm going to reiterate these 3 points as well in subsequent charts, but I will move on to the next slide. I always have this problem of navigating it to the next chart. I don't know, especially in the presentation notes. Okay. Now let us talk about. I'm hearing some echo. Can I use the organizers? I don't know what to do, but okay.
Yes, ma'am, I'm just trying it.
Thank you. Sorry about that.
Yes.
So let us start with the fundamental things, frameworks. So you have been hearing AI, big data, cloud, edge computing, so many things, right? But how to put everything into perspective? I always ensure that you start with an embryonic stuff, which is the framework, and then it is very easy for you to relate these stuff, and then kind of dwell deeper and deeper and deeper, right? So the emerging trends in the industry, artificial intelligence, obviously, then big data, the cloud computing, edge computing, and quantum. But today we are going to talk more about the AI. However, the building block or the core dependency interrelation of AI is the information architecture, which is enabled by big data. So without a proper information architecture framework, you will not have a proper AI at all. So poor data quality or other aspects, AI is not going, you're not going to, I mean, I don't want to give negative things. There will be a challenge in the AI. So it is very important for us to address the information architecture before getting into AI. So organizations which directly jump into AI are going to have a huge challenge in the information architecture space if they don't sort out this to actually cater. I'm not saying that 100% it should be right, because information architecture has been built over a period of time. You might have a lot of data quality issues and so on, but it's very, very important to consider. Then those two are intertwined with each other. So cloud, why is cloud, what is the relationship between this and that, right? So in cloud you have multiple, I'll just spend a minute on this because but our topic is going to be AI, don't worry about it. In cloud you have, it's like you know, a containerized environment meant to actually kind of scale and give you high availability, and it's rental. You can go and rent it at various flavors, right? You can rent a bare metal, or you can actually rent, you know, a platform as a service or software as a service, multiple things on this. But this is going to be a home for the AI as well as the big data. It might be, because the industry is trending and the applications which you develop or capabilities which you develop in AI are meant to get into cloud. And in cloud as well, there are multiple flavors, right? So you have hybrid cloud, which is actually within the organization's internal cloud, external cloud, or combined, or, you know, cloud. So today the industry is trending towards cloud across multiple cloud providers. So that means you pull some services from IBM Cloud, you pull some services from Google Cloud, and then kind of host all this and host your core application or application logic in AWS Cloud. So that is again a multi-vendor environment. And I know it is very confusing, but if you understand the basic principles, it's very easy and you guys will crack it out. And then edge computing, right? Edge computing is where, you know, you don't want to actually percolate the data into the core of the network. Rather, whatever you wanted to do, you can do in the periphery. So that is the edge computing. And quantum computing is a different way of computing. To be honest, I myself did not understand deeper part of quantum computing. But anyway, these are the industry trends today we do have. Now let us focus on AI. Okay. In AI, simple thing, let us start understanding with the stack. So this is the stack which our Executive Vice President Rob Thomas actually launched in the market to enable easy understanding and consumption, right? I have actually put this because I personally felt it is very easy to understand. At the bottom, as I said, AI sits on the top of the IA, but it doesn't mean that AI can also be a part of IA itself, the information architecture. That means, for example, if you want to process data quality, you can have AI as well. So it's like, it's both are intertwined, but foundational building block for AI is IA, information architecture, okay? First thing you need is to go and connect the data, then prepare the connect data, various sources, data unstructured, structured, different velocities, various patterns spread across multiple sources and so on. So you need a strong connection layer. Then you got to prepare the data. So preparing the data for what is the business case you're trying to solve, right? So I'm going to talk to you about in the CRISP-DM methodology, which is easy for you to understand. And you got to prepare the data. And then comes analyzing the data. This is where actually, you know, the models, you start building the models, you actually deploy the models to ideally, you know, you reiterate multiple times depending upon the type of algorithm you chose, and then kind of infuse it. Infuse is putting the model into production, which is a very important thing because, you know, once a model is, ideally, once the models are put into you got to seamlessly transition the model from development to production. But the other important thing is as well to monitor the model continuously, right? So whether the model degrades or what you got to do and so on. So this is a foundation framework. And if you see these lower level capabilities, the tools, what you see in the industry, or, you know, the capabilities, what you build, all will actually form into one of these frameworks. I really wanted to set the context for you. I'm sure that it's helpful to you. But let's look into the other part of it, right? There is I'm sure many of the data scientists, you know, people who are in this, who are in the in the call listening to you students, you might be knowing the CRISP-DM methodology. It has been in the industry for a while, right? So you start this is a flow of the information architecture life cycle. I wanted to insist, the reason why I intentionally put this chart here is I wanted to insist this particular message to you. Data science means, or being a data scientist does not mean that you should be only good in developing models. Oh, I develop models, I know the algorithms in the field, and I am good at Python and R programming or Scala programming, and I know to build models. You're not a data scientist. You are a subset of a data scientist. A data scientist has to look into the entire thing, right? So that is when you see, and that's very, very important. You always start with what is the business problem. And this is a CRISP-DM method adapted to IBM's portfolio as well. So you understand the business, what is the business problem which you are trying to solve, right? So if I say that I just take a .csv, run a Bayesian algorithm, a simple algorithm I'm saying, and then I create like a classification model, or I just do some regression and so on, it doesn't mean that I'm a data scientist. You should know what business problem you're trying to solve. Start with the business problem. Business alignment is very, very important. I'm going to talk to you about that as well in the next chart. Okay, once you know what is a business problem, you try to look into the data domains. What are these domains which it is playing? Take my simple example. All of you will have bank accounts, right? So as time lapses, or some of your family members, dad or mom, might have applied for a loan in the bank, right? So you fill in an application and send it to the bank. What does the case officer do? Case officer assesses loan approved or not approved. Now, the case officer taking a decision is a very classic example where you can put a model, an AI-based model to work, right? So what you are trying to do, you are actually starting with the business use case, the problem to actually reduce the time of a business or an evaluator, a bank, a loan officer, whomever it is, right? His time to actually kind of evaluate and support, right? That's the business problem you are trying to solve. Then you get into the next level. What is the data? The classic example for a loan application, your contact details, your income, your age, your gender, and then what is your credit history and so on. Those are all the data domains which you need to play on. Here you will need to engage a strong SME as well, right? Exactly, the case officer sits with you and tells you what are the key things which the data points which you need to look in. Then you work with the data engineer to go and figure out, or the enterprise architect to figure out where this data is actually coming from. The data source could be, customer relationship management database, or it could be as well for credit history. Sometimes you might need to process an unstructured data as well. So the data sources, then you're identifying the patterns of the data and so on. So that is the second aspect of it. After ideally processing the data, what does it mean? So it doesn't mean that you might have millions of records of data and so on. So you might not be actually taking all the data, right? So you might be doing some statistical modeling. I don't want to I'm not interested in this data ABCD, but I just wanted to do a random sampling, or I might do stratified sampling. That's something which we call as feature engineering as well. So it's both statistical and traditional processing of data, right? And then at this time, you will have an idea of what type of models which you wanted to bring into for solving this problem, right? So you identify when I say models, ideally it's algorithms. So you might have 3 or 4 algorithms which might suit for this. So looking at the data patterns, looking at the data footprint and so on, you might want to actually figure out the feature in the feature engineering. You might figure out that 4 models or 5 models I am really wanting to do. It could be supervised or it could be unsupervised, whatever it is. Then you actually start to pull up the training data, testing data. You do all this, the k-fold mechanism to actually test, train and test and so on, right? And then you as well have a goal of the precision recall or MAPI, whatever it is, depending upon the algorithm. You iterate. Then you're ready, and then you push it for deployment to put the model into work. Now, as I said, the CRISP-DM method actually stops at deployment, but in IBM, we have extended it to further level to figure out how the model is performing in the field, right? So why the model's performance might be actually degrading in the field? That's because it was not trained in the data which it saw. Example, again, the business loan example, if the model was trained in a data set which had just the age group of, for some reason, right, when you picked up it, it actually figured out, it was trained in the age group of 30 to 35, but at runtime, when the data comes in where the age was 60, then certainly the model will not know what to do. The confidence of the model will be very less to take the decision, right? Whether the loan has to be approved or not. So you got to actually consistently monitor and then figure out what you need to do in order to make the model better at field and so on. It's like just like a human, right? You as well train the human, you actually make the human take an exam, and then you actually practically as well keep monitoring on. So it's exactly the same concept. So that's, and in the middle runs AI governance. That is one another trend the industry is going on, because who actually developed, who qualified the model for actually taking up into various stages, who identified the data sources, the entire workflow and the governance around that, right? So that's the AI governance, which is trending in the industry. That's something which I wanted to call out. And obviously the heart of it is actually data. I'm doing a cross time check here. So let me actually go to, I hope that this actually set the context for you. But the key takeaway, which I really wanted to infuse into your brain is, think of this framework, think of cloud as an enabler, and then the typical AI life cycle actually evolves only around this. Then you go and crack. You guys go on, easy for you to break into lower components. Easy? Okay. Let's now delve deeper into what are the industry next level more, right? I go and teach data science for clients, as well as a lot of my teams worldwide across IBM. So I always try to actually start with this framework and then go deeper so that it is easy to comprehend. The same model is what I have adopted for you. Let's see what are the AI trends. Now, the first thing I wanted to actually help you understand is the AI interfaces. Many of you today, you might know that as soon as you open up a website, right, the virtual assistant comes up. That is the primitive text-based interface, AI interface, which you interact with. Okay. And then the next level of advancement is actually the virtual avatars. The virtual avatar is actually some virtual picture sitting and showing expressions like this, and so on. So that is one another interface which the AI portrays itself or manifests itself. Then the third one is obviously, the robots, the kinematic robots. I used to work extensively in the research of robots actually with IBM, but we actually put the robots to work in the field, but it had some problems. And then when I say problems, limitations in terms of speech to text, where, it was not able to, like humans, it was not able to actually pick up one particular signal and then start to respond. So if it starts to, in other words, hear some signal, it will start to respond. We actually, speech to text had an issue. So we put back to the research, and still we are working on, going forward with that. Then what type of AI interface you have? Embodied cognition. A room can talk to you, right? Your car can talk to you. So that's again another type of invisible interface you can call. So at the back end, these interfaces are going to differ, but the processing capabilities at the back end are going to be pretty much the same, right? So first is, we talked about the AI interfaces, and in the interfaces you have, these are supported by other supplements as well. Like for the first one is the vision. The vision interface is something, built on cameras, streaming cameras, or pictures and so on. That is one interface. Then the speech to text resembles a human ear, right? Speech to text, both the human ear and the tongue, for example, to speak. Nose is only thing which we are as well working. There is a lot of research going on in our research labs, but that's one thing as well, which mimics the human interfaces as well. But these are the core interface, AI interface, which you will be interacting with. Then let's talk about this AI embodiment. As I said, embodied cognition or AI embodiment is something which, as I told you, the room as well becomes AI, and the car becomes AI. So that's all embodied or infused cognition. It does not have a certain way to sort of manifest itself, but it becomes infused within there. So that is another thing which is AI embodiment we call. And then I want to talk about context-aware AI. Context-aware AI is, so the entire thing, right? Think of it like AI is nothing but, you are making the missions similar to humans. That's the fundamental foundation building block, right? And context-aware AI is something which remembers the earlier context. It remembers your urgency as well. I did a lot of patterns in the virtual assistant as well, right? So how do you find out that even in the text, right? How do you find this person who's actually in an emergency situation, and accordingly you align the other things and respond and so on. So that is one example of context aware AI. But context aware AI in simplicity is able to identify your location and space and time, right? So location and time, and then it is able to respond and so on. So that is context aware as a simple example I could give you, but there are complex stuff as well. Now, let me talk about the pseudo AI. What is pseudo AI? Traditional systems have been there, they might be older than me, right? So, but because AI came up, we are not in a position to throw them. The thing is, how do we leverage or give a flavor of AI to these traditional systems? That is one another complex part, right? I'm going to talk to you about one use case in the mining industry, which I built in even in 2015, right? So it's called pseudo AI. What you do is you take the traditional system, put an AI flavor on a facade on top of it. So to the human, it doesn't look like as if a traditional system is at the back end, but the traditional system will be morphed or will mimic a flavor of AI. So that is called pseudo AI. And AI as a skill. So in this ecosystem, each capability learns itself. So that is one another advancement, right? Like through self-exploration, or by actually kind of processing external voluntarily processing the corpus basis, knowledge base, and then it actually acquires a skill. Just like humans, we acquire a skill. Then what we do? Whatever I have now learned, I am teaching to you, right? So similarly, this is actually every skill the AI learns, it gets published to a common hub, and that skill actually gets inherited by others who need it as well. So that is called skill acquisition. After learning, put it into this, and the cognition amplifies. You can think of multiple n number of human brains actually within a particular corpus, and you can, or a particular in a hub, and that gets actually leveraged by someone else. So that is something which is a concept of AI skill brings in. But again, AI amplification has got two things. As I said, one is the skill this AI capability learns, published to somewhere, the common hub can be leveraged. So that is amplification, because you build the AI capabilities across. And also it is like, in traditional applications, you as I said, you put a facade in front. That is one part of it. But at the same time, I in my earlier role as well, I was specializing in, I specialize in actually kind of, taking a traditional application and how do you actually make it AI within itself? How do you put various capabilities within it to make itself AI? So the amplification, the cognition amplification, or the AI amplifies. Or how do you actually integrate this capability with external AI capability? For example, right, if I feel that Google's speech to text is very good, then I can go and figure out how I create an adapter to seamlessly integrate with it. So I am increasing the cognition or I am doing a cognition amplification here. I'll give a pause. I just wanted to ask you, is it interesting? Students, put up your hands. I'm not able to see your interesting, boring on a Saturday in the morning, getting ready for lunch. Okay, thank you. Wish it was a face-to-face session, right? I would have given you chocolates. Okay, the next one is actually AI reproducibility. AI reproducibility is another trend. How do you reproduce a particular decision, or a particular decision could be classification, the label-based classification, or it could be actually, a prediction score, for example, right? How do you reproduce it? Again, as humans, sometimes we take decisions based on, many times we take decisions based on the external factors. Same decision would have been different if, the external factors were different, right? So how do you actually reproduce this? And you actually make the system take the same decision and so on. That's called AI reproducibility. That is one another thing. And the second one, the last one, okay, light and heavy weighted corpus, right? So at the backend processing, think of, sometimes you might actually kind of need to process in a shallow level of knowledge base. I'll give you an example shortly. And sometimes you need to actually process in a massive amount of data. Again, back to humans. If somebody asks a question, I don't know, maybe I know Dr. Arun in this call, so I'll just take the privilege, right? If I tell Dr. Arun, good morning, right? So how he comprehends is, first is he figures out what is the focus of the question. The focus is greeting, right? I am greeting, I am receiving a greeting call from Gandhi. Now, he immediately, his brain processes like in terms of, how are you means like, or I'll take another example. Good morning, Dr. Arun. So that is a greeting, and I am just telling a good morning. So he will be actually, okay, greetings. I have to respond like good morning, Gandhi. That's it. Doesn't need to think lower. On the other hand, if I ask a question, Dr. Arun, can you actually tell me for a feature set of 100 features, what algorithms do you think would fit this, right, with this industry? So it's not like a shallow, immediate response. So he has to think deeper and give. Exactly the same model is replicated in the AI systems. So if frequently asked questions, right, that chatbot, what you see, the virtual agents, you can just ask a question, hello, it immediately responds like hello. And if you ask a question, tell me the transaction history for past 1 month, then it has to go process in a huge corpus, and then huge corpus, it will also go and pick up from the traditional systems and bring in. So that is the example of heavy weighted corpus, millions of records as well. In reality, we go on actually kind of process at the back end, right? And the corpus processing itself differs for these two categories. Okay. And that is one thing I wanted to actually call out. Then the other thing is multi-vendor, multi-cloud environment, which we touched upon, right? So different flavors, different patterns coming from different people, then I should have an ability to mix and match and create my own AI application or solution. So that is another trend in the industry today that has got a lot of challenges to solve, right from ID management, right? So if I have an AWS ID, then how do I go and consume IBM's maybe I'll give a virtual assistant or Watson assistant from IBM, Google speech to text. How do I do? So right from that all the way until billing and so on, there are multiple challenges which we are trying to solve in the industry. Okay. Then doing a time check here. So we are good at time. Foundational models is one other capability which the industry is trending. Just Google for foundational models, you will see what it is about, right? So the industry today is struggling for actually data, right? To train the models, you need more data. You don't want to overfit the model or you don't want to underfit the model. But realizing if I actually create a model to solve a problem, think of it like this particular data footprint I am operating is confined to that solving that particular business problem alone. It's like 101. You understood, right? On the other hand, think of, this 101 itself has got its own problems. One is data, and another thing as well, right? I cannot use this for something else, this intelligence for something else. Think of what if I have a model which is built on huge data set, and then on top of it I put models which could adapt to my requirements, like the hub and spoke stuff. That is exactly is called foundational models. And there is a lot of research which is going on in this, especially it's not as easy as we think, but it's a very complex thing which we are trying to crack. That is one thing which I wanted to call out. Okay, now let us very quickly go through each of this, and then I will give you an example, exciting example from the mining or engineering industry. Strong interlock with the business. You saw whatever are your problems. Long ago, I used to go and meet a lot of client CEOs across the globe, right? When I used to talk them, okay, I have a team of, they say, I have a team of 15 or so many PhDs and PhDs. And okay, what models you create? Oh yeah, we create ABCD models. How many models you put into work? Oh, no. So it means one is they are not aligned with the business, or the business is not having confidence on the models which you develop to put at work. So two things, right? So a strong interlock with the business is needed. The second thing is you need a single workbench to handle, IA and AI together, which we saw in the earlier thing, right? Because you don't want to keep on navigating across multiple tools and so on. So that is one trend. Converge 2 is one another trend. I've broken down into lower components to help you understand easily. I can talk about concepts, but that might not help you much. So that's the reason I intentionally put here. Then diverse data scientists. So, millennials like you guys will love Python programming. Some people might love R. People like me might love Scala, right? So how many, and some people might really don't want to actually crack the code. They want like a drag and drop stuff. Now you need a tool to actually kind of cater to all the needs, the multiple flavors of people, data scientists. So that is one another convergence to cater to multiple diverse data scientists is what is another trend I could see at a lower level. And then embrace open source. Open source is a rich stuff, but how does your tool embrace open stuff? is one another thing I could, the tools aligning to cater to open source is another thing which I could see. And data understanding, as I said, right? So data stuff is actually understanding the data, cataloging the data, making the data available for others to use as well. Prepare, because others will be wasting time in actually preparing the data. You don't want to reinvent the wheel, right? So it has to be properly cataloged and then published for others to use and collaborate. So that is another thing where I could see a strong focus, which is going on in the industry. And then the layered data preparation, right? So you might want to prepare data within closer to the data itself. So I wanted to tell you one another thing here, right? So you have the data located here, okay, big data layer, and then you have the data science platform operating on it. So how cool will it be if you push your models from the top and then execute the models closer to the data itself? That is called remote execution. It's a fantastic capability, which I felt very good to learn and very interesting to actually apply at clients, right? So processing data closest to the data is what you can take. That's called remote execution. Sometimes people call it as SQL push. So that is layered data. You can apply in data preparation, or you can even do in training, model training, or as well production and so on. So that's something I wanted to call out. And obviously applying AI in even data quality and so on. So that is something which is there. And statistical processing of data, which we touched upon, and infused and external AI, which we touched upon, right? Within a core application, traditional application, how you bring in AI, and then how do you leverage the external one, and modeling. It's not, and as you know, AI models are all probabilistic, right? It's not that we throw a deterministic stuff away. How do you leverage these two to solve your business problem is very important. So you need a tool to actually converge these two together. Always remember that it's not all the time AI just going to solve your problem. It will be, you may land up in cases where, especially if you look at finance industry and so on, right? Or mission critical decisions and so on, you might actually want to nail down. You don't even want to go into AI. You might say that, guys, we'll go and do a deterministic model, or you combine these two together. So that's something which I wanted to tell you where the industry is converging. AutoML is nothing that, you as a data scientist, I know this many features. I might say, hey, look, these algorithms will fit into this, a naive Bayes, or you use a random forest for this particular feature sets and so on. But instead, how cool will it be that, you throw this feature set into the mission says that these are the top algorithms which match for you, and then you can start to do your work, right? So that is called AutoML. So that's something which the industry is trending, and I mean, already it is in there, and we are refining a lot there. And hyperparameter optimization is something, how many features you identify, the independent features, dependent features, or how this impact the output and so on. Some features might not even needed, and you might want to throw. So that is all about the feature engineering and the machine will be able to tell you even that you have advanced capabilities like that. And auto deployment, once you create and train your model, seamlessly push it into production. So that is a big pain in the industry. So and there are a lot of ideally from IBM, we do have tools which are maturing as well. So that is called model deployment. And model execution, I told you, right? So you can push the model close to the data itself. If you go and Google for Hadoop execution engine for IBM, you will see beautiful things around there, how the remote execution happens using the Livy connection and so on. It's a fantastic thing. And then obviously embrace cloud pattern. The solution you build needs to actually be mix and match, or whatever parts of it can reside here, there, and multiple clouds, multiple flavors, and so on. So in short, it should be flexible. Then, as I said, model bias reduction, how the model is performing, right? Monitoring means bias reduction and so on. So that is about, and explainability. Explainability is very important in a model in order to actually get the confidence of your business. If a model, again, our business, the banking example, right? If you go to the banking example and figure out why this loan was approved, then the case officer will be able to explain, right? Similarly, in order to gain the confidence of the business, the model should explain why it took a decision that it should reject or it should approve and so on. That's explainability. It's huge topic, huge amount of research which is going on in this model explainability. You might want to Google and figure out. So that is another key cool thing which is going on. And then I talked about foundational models. Okay. So time check, again, 18 minutes. I have 8 more minutes to cover, and then we'll take questions in the end. I wanted to give you an example in a mining industry, right? So these are reference clients for us. 2015 onwards, I told that is one of the biggest client for us, and I actually was nominated to lead that. I can name the clients, Woodside Energy, because they are our external reference clients, and you can go and look at cool things what IBM and Woodside did. And that's the mining industry. We solved n number of problems there and figured out what are the gaps. We started with a very joint, very small collaboration, but then we grew into a massive manner. So here, one of the key things is we started with a virtual assistant to help the offshore rig miners to figure out, right, this corpus, they actually kind of built more than 45, 50 years, this documents, right? And all they had very big attrition going on. And then, you know, in order to even figure out what is the problem, a simple problem, which I wanted, it's a funny problem, but I'll tell you, it was a big problem there. Offshore rigs, 80, 100 kilometers within the sea, right? They had all these seabirds coming and sitting in the rigs and so on, and causing all this menace. So they wanted to know what did the seniors did, or earlier, how did they handle this problem. They were trying to go through documents and you know, for days, and they were not able to figure out. But this virtual assistant we built on top of this massive corpus base, right, was able to give in few seconds. So that was the first the primitive problem which we solved. But then after that, you know, we also try to solve multiple things in terms of what are the hazardous things which can go in a mining industry. Let us say that, you know, mining industry, how it works, right? You qualify a particular area, explore that area is what we call, then we actually drill that particular area and figure out, when you drill, because of this oil and gas stuff, right? This explosion happens depending on the type of the environment and so on. They call it as, sometimes it throws off the mud and so on, right? So we call it as geohazards. So they wanted to figure out, if I'm exploring in this particular area, depending on the characteristics, where their previous cases are, what is the risk, right? So that is going to not only solve the problem proactively of this money saving, but it's also going to valuable human lives and so on. So that's one thing which we did as well. And going to engineering industry, one of the biggest clients here, I can't mention the name, but in Asia Pacific region, they were actually, you know, incurring millions of dollars actually lost because they were not complying to the standards, international standards. When they build these equipments for delivering across, they had to comply with standards, multiple standards, international standards, country level standards, local standards, and so on. So they wanted to reduce the risk, to figure out, if an RFP comes, what is the level, which requirements I got to closely look at, right? So I'll give you another beautiful example here, that it might say that the requirements say that the rolling stock is nothing but train. Rolling stock's speed shall not exceed 100 kilometers while it is snowing, and so on, right? So shall is a very key word there, whereas the requirements say may. So you got to get into that lower level and figure out what is the discrepancy, shall and may, and so on. So you got to break down into multiple components, then figure out what it is, and so on. So a neural parser based approach is what we built. It's a very complex problem, right? So I just thought I should look into this, mention this and that. And many industries, many banking industries on this loan approval process, I told you, right? A very simple thing, but that's a very first example we tell when when the banking industry comes to us for solutions and so on. Okay. And what I would encourage you students is just go through IBM statistics tool, which is meant predominantly for students. It's a university. Many universities use this, and I would recommend you to sign up and then see, explore. And beautiful manuals are there. Just go through and see how it actually, the entire CRISP-DM methodology which we spoke, right? You might not have monitoring and other things, but until model building and so on, you will have a very good feel of how to use it. And IBM Cloud Pak for data, it's a heavy weighted stuff, information architecture and AI together, and you'll have multiple capabilities and services to get a feel of whatever I spoke now, right? So it's now up to you to go and read through the documents and so on. Equip yourself. Now, 3 minutes. What are the key roles in this, right? As I said, important thing, just because you develop model, it does not mean you are a data scientist. You got to actually build your skills in this, all these things. Okay, that's the key takeaway from this. Now let's go to the data engineer role. Data engineers are the guys who actually predominantly work closely with the business understanding. They kind of look at what are the data domains and then kind of look into the data sources, identify what are the various flavors and so on. So that is one key role which you have in this in the CRISP-DM methodology, only ideally in the AI technology. Then you have the data scientist. Data scientist needs to look into this entire portfolio and then equip yourself to figure out, what are the data processing things which you need to do, and then models, what are the models which are there, and how do you actually kind of reduce the time, right? This feature engineering, and then as well, you can use the auto DO and so on, as I said, and ensure AI governance is in place right from the beginning. And then obviously, deployment and monitor and put the model to production. Main thing is the data scientist needs to very closely work with the business stakeholders to get the confidence. Otherwise, it's going to be a huge challenge, because the investment what your company makes as you start to work, or even ideally the project works, it's at even in your project work, right? In your current project work, I meant, you have to have a strong interlink with the business users, which is very important. And then there is one another role, which is the UI designer. So the UI designer actually is looking at how the UI should be, how there are a lot of innovation as well, which you can bring in there, how this UI can be made easy for people to consume, what are the other innovations which you can bring, and so on, self-supportive thing, right? So that is one thing which is in the industry a key hot role. And developer, designer and developer together. Then the supporting one, big data specialist, that is actually the next level of the data engineer, what you saw here. And then cloud specialist and cloud architect. So it's not that you are a cloud architect, being a cloud architect, core cloud architect, cloud specialist is one thing, but as a data scientist, as a data engineer, you should be knowing at least the basics of cloud architecture. Otherwise, you have to be in line, is what I meant. But if you want a deeper thing, you can engage them, but you should be aware of it. I am myself preparing for AWS architecture certification. I've been doing it for 2-3 months. Sorry. So 1 minute. I'll take 1 more minute. Create your brand. And when I say create your brand, right? How do you actually differentiate yourself? Or how do you, you should be in a position not to actually come and explain to me, I am very good in, this in modeling or whatever it is. So how do you actually do it? You actually need to get certified. Like as Dr. Shaurya was telling, right, in the earlier session. So you got to actually kind of go and do certifications, small certifications at whatever level you could do. You have to invest time besides your academic, in addition to your education. If you wanted to actually kind of grow, that is exactly I wanted to give as a key takeaway. Then align with the industry trends and the organization trends as you transition from being in the university to the work, to your employer. What the employer is really looking for is something which is very important. It's not that the employer is looking for you to sit for 16 hours and so on. Some employers might look, but what is the tangible outcome which you're doing and how you are aligned to your business unit? It could be testing, it could be development, or it could be whatever, right? That is another thing. Always look for what you need to do. Then long-term and short-term plans, very important. A dream always comes true is very well said. This thing, I 10 years ahead what you wanted to do, or 5 years ahead what you want to do. Then this particular year what you wanted to do. Every year during the Christmas period, I look back what I did and what I need to do in the next year is how. Sometimes things might get delayed, but there will be a lot of challenges, but eventually you will actually achieve it. So have a short-term and long-term plan. And confidence is very, very important. All of us are learning today, right? Even I am learning new technologies today. So it's not that, don't think that you got to actually kind of learn everything and then go. It's the courage and confidence with which you go and position yourself, which is what matters a lot. So that's one takeaway I wanted to give you. And consistent pace. Again, right, I did like Dr. Shaurya mentioning fire in the belly, continuous learning and, consistent perseverance. It's okay because you got to, it's not that career alone is your life, but you have to also focus on your family, especially when you get into the next stages. But always you figure out if you're good, you will do well in both. So that is something which I wanted to call out. Okay. Now, with that, I really wanted to actually open up the floor for questions. And yeah, thank you. I'll stop sharing.
Yeah, thank you so much, ma'am, for your encouraging and really informative talk. So I would like to ask the students if they have any questions, please come up. Yes. Anybody is having any question?
Students, you are asking questions, okay? Next time I meet, or I will ensure that your name is listed. I'll send chocolates to you. Okay? Come on, ask questions. Don't feel shy. Don't. This is the forum. You got to step up and ask questions. I'd like you to.
Good morning, ma'am.
Yeah.
Good afternoon. Yeah. Ma'am, I'm in UG2, and what projects can I pursue and what domains can I explore so that I can make projects on them and get internship or jobs at IBM or other companies?
So, sorry, I missed your name. You said UJ?
I'm from, my name is Shreyas Kasliwal. I'm from UG2. So
Okay.
what projects and domain can I explore?
So UG2 means you are in
Second
level
year.
Year 2. Is that what
Yes.
it means? Okay. So Shreyas, look at the practical problems. For example, as I said, right, what are the key business problem in the industry you wanted to solve, and so on. So it could be a particular let me give an example. For a particular group of customers, you wanted to actually these campaigns, you wanted to create campaigns, right? So you might take an example as an AI model, starting from that CRISP DM methodology, and what the evaluators expect is actually your exposure to these various dimensions. But you can take a common problem in the industry, which could be a telecom industry or even a banking or a retail industry, where you identify customer segmentation. Maybe you use a random forest methods, Diana or Agnes algorithm, and then you kind of look at the products and then do the match. So that could be a classic example I could give. Or you could actually, if you want very specific to a particular industry, this classic the bank loan evaluator, who actually either assesses your application and then says yes or no. Or you can see, if you want to go to this engineering industry, then you might want to figure out, you can take a problem of you wanted to predict the breakdown of a machine well in advance, right? So how do you do that? And those kind of things which you can think through across industry, and then you can figure out, do your research in regards to what are the most common problems in the industry, and then you can try to apply this DM method, and then try to come up with your solution. So try to create the solution, and then you start to code, and then do whatever you want. And as well, Dr. Shaurya was mentioning, right, Kaggle has got a lot of open data too. So you can actually sort of leverage data from there for your testing and so on, because data is a very, very key thing too. So I wanted to call it that. Does that answer your question, Shreya?
Yes, ma'am. Thank you.
Thank you. Any other questions? Students, I would expect you to ask me questions. So Shreyas is going to get a chocolate from me, okay? Who else?
Yes, please come up for questions. Yes.
I want to see smiling faces here. Energetic and smiling faces.
Good afternoon, ma'am. This is Naman from second year only. So, ma'am, I wanted to ask how to choose a domain in AI. Like, there are so many domains in AI, and it can be overwhelming sometimes to see there are so many things like computer vision, cloud computing, and many things. Like, how can I choose a domain which will last longer? And if by chance, if I choose a domain that does not, in 5 or 6 years or 10 years, if that domain is slowing, it is getting out of trend, so how will I make my transition easier, to changing the domain? How can I make that easier, and how can I do the transition?
Okay, so Namun, actually, if you look for a problem and then start with solving the problem, then it would actually help you out. So from the problem, you get into the data aspects, and again, it's easy to actually navigate you through the method, right? And then you say that my solution actually is going to reside in cloud AB. The models of the clouds might change, but the components are not going to ideally change. So logically, that is how it actually works. And I completely agree that, the industry is changing with utmost speed. And as I said, it's actually, even, ideally it's not even daily, I as well learn, right? So in order to keep up with the pace. So it's okay, even if it changes, it's okay. But the foundation blocks, what you learned, and as well the ability to actually kind of consistently learn is what is going to help you succeed. I don't know if I answered your question, Naman, but in short, pick up for use cases, business use cases, which are going to be, that, right, in the banking industry, this might not be. And again, identifying problems for a campaign management thing, and maybe mission breakdown. So these kind of things are going to be there in the industry. You can actually kind of narrow down to that level, and then look at the technology. As I said, technologies might change, but it's going to evolve, right? It's the foundation things are going to remain the same. The models might change, the models you apply might change and so on, but still it is going to be, logically, it's going to be the same, is what I meant. Does that answer your question, Naman?
Yes, ma'am. Thank you.
Yeah.
So we have another question, ma'am.
Sure.
Good afternoon, ma'am. I'm Rushendra from UG to CSE. So I wanted to ask you, so now our second year is going to end and we'll have a summer vacation soon, and this time we'll probably have a big one. So so when do you think is the right time to do an internship? Because I've been exploring ML for the last 1 year. I've been doing some courses and all. I believe I understand what it is about, and I understand some of the math behind it. So in this vacation, should I try for an internship or further try to build my foundation and concept?
So Kushendra, there is no time. You have to start immediately, is what I meant. But some organizations actually entertain interns at the final year. Some actually entertain in the pre-final year and so on. So you accordingly actually kind of reach out and figure out which organization is hiring. But you should actually start now. There is no day to actually wait. So you should start. That is my advice.
Yes,
okay?
Thank you, ma'am. Yeah.
So students, thank you very much for your time, and I thank the director KB for actually having me here, and Dr. Arun for his support. And students, I wish you all and pray you to actually come up with flourishing colors in the industry and with a stellar journey, and my prayers to Lord for that. Thank you all. Bye.
Yeah, thank you so much.
Thank you, Dr. Gandhi. I was in the session, but in between I took a break. Our fourth year students are in a village today. We have adopted 5 villages under Unnat Bharat Abhiyan scheme, and they were engaged with school students on teaching them hygiene and all that. So I just went to see how they are doing. So otherwise, I was listening to your session through my mobile. Thank you so much for joining, and nice to have Yalna to be part of the speakers.
Thank you, Professor. Much humbled, and thank you again for having me, and looking forward to continue the collaboration.
Yes. Thank you so much.
Thanks all. Bye.
Students, please be here. So we will have our chairman, Mr. M. Balasubramaniam, who will address you in few minutes. Please be here. Yes, good afternoon, sir.
Has joined.
Yes, sir.
I'm not able to see the video. You are able to see the video?
Yes, sir. We are able to see.
Yeah. Yes.
Yeah.
Okay. Good afternoon. Good afternoon. Your mic is, I think, mute. Okay. Welcome, and I think somebody is going to talk about the workshop to sort of summarize to the chairman. Aruna, somebody?
Very good afternoon, sir. Actually, very nice to see you here. Thank you, Director Sir, for giving me the opportunity to provide a summary. Actually, sir, this workshop to students as a whole. So this workshop, we are aiming to motivate our second year students, especially to take up this AML specialization. So already they have these introductory courses, as you are aware. And now this, we hope that this will provide them a motivation and also some awareness of the activities going on in the field, in the industry. So we have got some eminent experts from the industry. So the first speaker, we had Dr. Dattaraj Rao. So he talked about responsible AI, and then we also have Dr. Ramasuri Narayana from Senior Research Scientist from Adobe. So he was also, it was basically a talk which where he tried to advise the students how they can go forward, like how they can actually move forward and get an internship and get a placement, like what are the skill sets that they are expecting. And also he took some case studies and discussed from Adobe in Adobe what areas they are working on. And so we had a quite good question from the student side also in both the sessions. So that was the day one. Although we planned another speaker, Dr. Venkatesh Sarangan, due to some unfortunate incident in his family, he couldn't participate. But except that the two sessions were very informative, and the students were very, very interactive in those sessions. So today morning we had a session from Mr. Prantik Sen from Amazon. So where he also discussed about machine learning for computer vision and ASR in general. And he also took some case studies and also provided a general awareness about the skill set requirement and general trends in this area. And we also had a good questions. And then we also had a speaker, Dr. Shaurya Roy from Flipkart. So where he also discussed about AML in e-commerce with different interesting case studies. I hope our students really enjoyed, and some of them were coming out and they were asking questions. Although we had some questions which we collected through Google Forms, we could ask them that, but we had some direct interaction with our students. Students are coming forward. As you can see, they are physically here in the classroom. So they were quite interactive. And so we also had now the speaker, Dr. Gandhi. So so she also had a very good session, and that was a workshop as a whole, sir. So we hope that our students greatly benefited from these interactions, and students as a whole, although exams are coming soon, and there were many submissions towards the end and many issues, I mean the academic stress, but apart from that, they had shown a very keen interest and they were actively participating. I hope all of them will greatly benefit from this workshop. And thank you, sir, for being here and supporting us. And thank you, Director, sir, for the opportunity. Thank you. Thank you. Over to you, sir.
Thank you, Professor Dr. Arun. A very good afternoon, everybody. Hi to everybody. You can wave your hands. Hi. Good to see you all. So nice, so nice. Professor, dear students, and Professor Dr. Kannabiran, dedicated professors, Dr. Arun, very good afternoon and a warm welcome and namaste to everyone. In fact, it's been an interesting time for me because I take this opportunity to welcome you all to the campus. That's something very, very important because after almost 16 months since you all have joined, I think a few weeks back, you're on the campus. And if I'm not wrong, second time I'm meeting you all as together, right? I should have been in the campus, but I've been traveling. I'm in Delhi for various official reasons. I remember 2nd December 2020 is the day your induction program happened, and I happened to meet you all virtually. And that was my first meeting as well after joining as a chairman of IIIT CCT. And I hope all is well with you and your family. That's very, very important. So I think, yeah, Professor Dr. Arun apprised the 2 days, 2 half-a-day workshop. It's been very interesting to know. The most exciting thing for me is a lot of you students ask questions. That is very, very important. So I'm happy that you're asking questions. And in fact, for going forward, it should be a dynamic questions. I mean, I wouldn't expect you to send your questions in a form or a Word document, but rather you should have the capability and the willingness to stand up and ask questions, because unless you ask, and the crying baby only gets the milk. Unless you ask, you will not find a solution at all. I'm sure students, know this 2 half-a-day workshop would have got you an enormous opportunity to understand the trends and the career opportunities. As you all know, AI is not a new subject, right? Although we call itself as an emerging technology or a deep technology. When I was a student, say 20 years back, even those days we used to present paper in AI. So AI is not a new subject, but rather the trends, opportunities, the use cases, those things have changed. I think more than theoretically studying in the curriculum, I think more important for all of you is to practically have the use cases. And I'm sure, especially this 2 half-a-day, when I was able to see the agenda, I was so happy because almost everybody are from the industry. So although the time is very, very short, I think that's enough for you as a second year students to understand the fundamentals of all the topics that I've discussed, and you can embrace the opportunities that are there. So I'm not going to talk anymore about AI or ML because I think 2 days would have got you enough information. So rather, I will casually share some of my perspectives, how the things are moving ahead, and where you should focus as an industry leader with the 2 decades of experience working with various multinational companies and working with 300 plus deep dive startups. I just wanted to share some of my perspectives as second year students where you may want to focus your thoughts, right? So, as you know, our country has strived and thrived excellently in the economic development within the ecosystem. And more importantly, the school education and higher education was focused well. I think it got good streamlining happened in the last 20 months or so. As you know, $2.7 trillion economy in 21 for India, which is aimed at $8.2 trillion in 2030, right? And I think it's achievable. And please understand, my dear friends, IT is no more a vertical, it is a horizontal, right? So irrespective of any sector, any domain, IT is going to play a predominant role. Now, IT is no more a subject, it is horizontal. I mean, without IT, the world cannot survive. That's how the things have been going on. And which means we will overtake Japan. We will overtake, which is Asia's second largest economy. We will surpass Germany, UK, France. It's interesting. If you look at the vision of our Ministry of Education and the Ministry of Information Technology, they thoroughly encourage the extensive collaboration between the government, the IT industry, and the academia. And that is what we call co-creating the ecosystem and including the startups and so on and so forth. And since I come from the industry and our Professor Dr. Kanabiran, director, comes from academic and the management background, I think this combination truly helps us to structure a very unique a framework for our IIIT students. So we have driven a critical path and successfully demonstrated globally. Of course, the COVID impact everywhere, but India emerged as a very clear demonstration of the driving the efficiency and more importantly, the resiliency, right? The highest attainment of resiliency in the world is from India. As an industry, I run the CXO Council for the South India, that comprising of 300 plus multinational company CEOs. So it was very clearly demonstrated and very clearly accorded by everybody that India has clearly demonstrated. But having said that, they're talking about fourth wave, right? So change will continue to be the only constant in 21, 22, probably even 23. But our ability to continually adapt to the success, that's what is going to determine where we are going to move forward, right? In fact, I estimate, probably you all will agree, 3 years worth of innovation, 3 years worth of the thought process innovation have actually completed with this international SOAs in few weeks or few months, right? So innovation, even with the challenging budgets, has allowed us to take the risk registers in order to prioritize the future practices, and the concern over the digital growth have now been matched by the health and well-being. Of course, that's why I asked you, anyone I see you, now I see them, I'm going to ask them, how are they, the family as well? So health and well-being plays a major role because the pandemic has reminded us no machine is going to function without humans, right? I think this is an important sentence I would like to make, especially when we talk about AI, ML. Irrespective of so-called emerging technologies or the deep technologies, nothing is going to work without humans. So the myth that AI, ML is going to cut down the jobs, and all those things, myths been discussed among the industry at various conferences and workshops, but without humans, these things are not going to function. Having said that, the key word I would like to share with you, and which I wanted you to keep thinking about it, and I'm sure I'll be in the campus soon, and I would like to talk to you in person. The future of work, right? The future are always no reaction to the present. And tomorrow is always judgment on today. And by training a microscope on how we work now, we can try to figure out we are going to work on this day's time, right? So though the future of work will always be a future, and the future of work has never been closer, be it rise of robots, the gig labor, or the machine intelligence, or distributed ledger, the quantum physics, the unexaggerated death of privacy. So all this trending point of the new world that is shaping us quite differently, anything that we've ever seen or worked in the before. And if you look at SMAC, I'm sure you would have come across the word SMAC, the social, mobile, analytic, and cloud technology, which have fundamentally challenged every business. Today, you take any sector, the SMAC has made a big challenge. And if you look at, I call as FAANG's success story. I don't know whether you've come across the word FAANG. FAANG is nothing but the Facebook, Apple, Amazon, Netflix, and Google, which have been at the heart. We call it as FAANG's success story that become deep seats and an era of surveillance of capitalism, right? So when we call out the importance of customer experience and the potential of augmented reality, we all laid out a game plan for humans and coming times the permissions for everything, including the proposed job of the future, right? That is something very, very important. So keep in mind the future of work is very important. Probably a quick themes of future of work. I think at this second year, if you start thinking about the future of work, how it emerges. See, technology is only enabler, my dear friends. Anybody can learn technology. I mean, it all depends on your interest level, passion, and commitment. You can do that in 2 weeks or 2 months or 2 years. So for me, technology is not the big botheration, rather looking at where the future trends of work is going around, right? So either you should work or you should give work to somebody, right? These are the two options, or you may go for an higher education, right? These are the three major opportunities you're going to do after the completion of your BTech degree from prestigious IIIT City. So you need to understand how the future of work themes are evolving, right? Number one, the way we work, right? How to be and what we do, right? That is very, very important. Number two, the tools that we work, the systems, the processes, the applications, network, those are the things that make us to work. Number three, the aesthetics of the work, what works look like and how it feels for us, right? The aesthetic of the work. Number four, the issues with the work, when and why work is a work, right? The issues. And the fifth one, my dear friends, is what is the meaning of work, right? What gets out of the bed today and make us to feel proud. So these are the fundamental themes that is covered under the work, future of work. What we work, the way we work, the tools of the work, the aesthetics of the work, the issues with the work, and what is the meaning of work. When you look at ranging across technologies, business models, demographics, the outline what we consider the most important trends will change, and what we do and how we do, whether we are a chief executive or a student or a politician or a college professor or a salaried employee, it remains the same. So what I'm trying to say here, apart from the ranging technologies that emerges, apart from the business models and various change in the demographics, the most important is what we do and how we do the work is what going to determine. And when you look at today, the new emerging digital ecosystem across the country, across the globe, say healthcare for all, no education for all, no job and skills for the all, doubling farmers' income, no next generation financial services, no making in digital India, no e-governance for the world, energy for all. So all these things, if you look at it, all coin around the digital ecosystem across the world. And if you look at past 5 years, we have seen a tremendous change that emerged the world, especially in higher education. Right? You see the fundamental changes in higher education. One such key changes is incubation. Right? Today, even in our college, we have technology business incubator, and I wish the students should start more. I mean, instead of a lot of outside people getting into the TBA, it's not that, but I wish the students of IIIT should take this opportunity. You are anyway staying inside the campus. Use that opportunity to be an in-house entrepreneur. Try to come with a thought process. Put up, prototype and come with an MVP. You have a person like me, person like director, who can put your thoughts together and try to make your idea come into reality that benefits the government, that benefits the public, that benefits some industry. It could be whatever. So fundamentally, a huge change has happened in the incubator space. So I wish the students should spend more time. Probably director may arrange a session about the technology business incubator and how students can make use of it. And second thing which I wanted to say very clearly is something, the reality, the practicality, because as an industry expert, I just wanted to say this is how I look at higher education. But today the students want more from higher education. It's not just the degree or the participation in academic canon are no longer the top priorities for the students. Instead, you guys wanted to be the next Steve Jobs. You guys wanted to be the next Nikola Tesla, right? So that is how the students' perception is, or expectations are going towards. So they know that degree is not required for success in Silicon Valley, or leave Silicon Valley, even anything, any success, degree alone is not going to be required. And this is what the Google and the PayPal, everybody shout loudly, is very loudly. If you look at the statistics that tell us higher education still matters a lot. So having said that, the reality is what I said, but that doesn't mean you can ignore higher education. That's really important. And we know a few years of young people have to focus solely on learning before entering into professional life. That is very, very precious, right? So you need to ensure your present situation, present time has to be embraced successfully, and because they are the catalytic, they are the transformative, and the way that you design for the years to come is going to be finally challenging too. You need to see the competitiveness that emerge across technology, across the business models, across the industries and domains. Everything is changed day by day, right? Today, if you're a manufacturing company, tomorrow morning when you get up, it's going to be an IT company or even a digital company for that matter, right? So the students can get the best world's lecture online via YouTube, so that the universities have to offer more. So all that's fine, but you need to fuse the real world problems with the kind of nurturing environment dedicated to the ideas and wonder and inspire the drives towards the best academic inquiry. I think our ecosystem, especially in IEEE History City, if you look at our professors, they are highly, highly equipped in terms of not only the academic stuff, but also what the industry demands. I think that is how we've been very conscious in identifying the right professors, right ecosystem for our institution. And if you look at, here is going to be the very seismic shift. That is how the universities teach, and they relate themselves to the worlds after college when students make a leap to their professional life. So having said that, my dear friends, I think this 2 half-a-day workshop would have got you definitely a better perspective from what was there in the paper and books. But today you had an opportunity to talk to an industry expert, and if you look at where education needs innovation, where ideas now leads to a successful startup, where life is immersed in technology, where pathways are created across for global success, where passion and purpose come together and realize your dream, not our dream, but it's your dream, because your dream and your parents' dream and your passion and commitment, that's where it's going to drive the success. And for the students of IIIT, it's not just about the learning, but it's more importantly, the learning revolution. I think this learning revolution is going to make all of us successful forever. That's going to benefit not only our nation, but the entire world, right? So I think with this short span of time, I think this is what the share I wish to give, but I would certainly visit the college sometime, institution sometime soon, would like to talk to you, meet you, share some of the perspectives and answer any questions, and wishing you all the very best. Thanks, Professor Dr. Kanabiran, for organizing this very important workshop, and wishing you all the very best. Enjoy the rest of your 1.5 day of weekend. God bless. Jai Hind. Thank you.
Thank you so much, sir, for sharing your perspective with our students. And thank you for being here and encourage our students by your kind words. And with this, I would like to invite Dr. Arun to give the vote of thanks.
Thank you very much, ma'am, and for giving me this opportunity. And thank you, sir, for the kind words. So and now my duty bestowed upon me is to thank all. So I consider it as a great privilege to get this opportunity. So first of all, I would like to thank our beloved chairman, sir, for his kind words of wisdom. Sir, like every time we hear your words, actually we are learning a lot from you. Like you have a diverse experience in the field of industry as well as in education. So actually you are the one, I mean, whom we are looking forward in getting the guidance regarding how we can take up our education sector forward. As young faculty, actually we look forward to you, and thank you for your words of wisdom, and thank you for your encouragement and your participation in this workshop. Thank you, sir. I hope our students are also greatly benefited by your words. I mean, so they were hearing a lot of sessions, and I think these words from you will actually help them to consolidate the knowledge that they have gained through this workshop. Thank you so much, sir. And now next, our director, sir, as all of us know, he's the facilitator behind this workshop. Thank you very much, sir, for organizing such a very nice workshop. And thank you for guiding us with all the support. And so because although we organized this workshop in a short period of time, we were having back-to-back meetings, and all guidance and support we were getting from you. Thank you so much, sir, for the kind support. Now, the best part of or one of the key part of this workshop are the speakers. We were very lucky to have very good speakers, eminent leaders from the industry. So we had Dr. Dattaraj Rao, Chief Data Scientist from Persistent Systems. We had Dr. Venkatesh Sarangan, Dr. Ramasuri Narayanam. We had Prantik Sen, Dr. Shaurya Roy, Dr. Gandhi Shivakumar. And so we are, although we informed them in a, this is a workshop for the second year students, and they all their talks were highly intuitive and were highly beneficial to our students. So we greatly thank them. They are not now online, but we would like to express our word of thanks to all of them, all our speakers. And now a very important part of our workshop is our students. Now we all know that this is a session where the exams are going on, they have and some assignments, all these things. But despite of that, all our students are participating enthusiastically in the workshop. And I hope it will greatly benefit them, it will help them to get internships, to get placements. And not only that, as directors, as chairman has suggested, it will help them to actually become a good contributors in the society, either as entrepreneurs or as technologists in either way. Thank you all our students for your kind participation. And now I would like to thank all my colleagues, especially the organizing team. We had Dr. Piyush Joshi, Dr. Priyamvada Subudhi, Dr. Rakesh Senodia, Dr. Anusri Bablani. And so we were a team, and so that is how we could put forward this workshop, and they were there for all the support, everything. So thank you all for your kind efforts. We greatly appreciate that. I hope this is a contribution from our side to the students, and thank you all for your kind efforts. And last but not the least, all the staff, actually Vijay and many other people were greatly involved in this workshop, because we are conducting a hybrid mode. So thank you all for your kind cooperation. And we also thank all the other faculties and all the other persons for their kind support. Thank you again, and thank you students, and Chairman sir, thank you, Director sir, and all the faculties, everyone, thank you once again. So we will wind up the session. Jai Hind, thank you.
Thank you. Professor, I can leave?
You may leave the meeting, sir. Thank
all
you.
Right. Thank you. Bye, friends. I'll see you all. Thank you. Bye-bye.
Thank you. Students, please stay back. Our director sir will be addressing.
Yeah, I'm there. Okay, I'm not going to give a talk or anything. I will only speak to you for a few minutes. So I don't know how many of you seriously attend this workshop. I've been watching. There are some students having fun talking to their neighbor and all that. But the only thing that I'm telling you, you spend 3 semesters at home, okay, and you have come to the college. Very enthusiastically you came, and all of you came January 5th, we started. And I don't know, you must be talking to the students of other institutes. We are the first IIIT to bring back students, that is your class of let's say UG2 students from January. Okay, and you enthusiastically came, you participated in every activity, Republic Day, all of you were there, and other activities you were participating. But when it comes to academic activity, when we are trying to get people, and when you want to do workshops, and somehow I felt that you need to be, really called, chased, and you are not voluntarily coming. That's what is sort of upsetting me. When we have taken a lot of efforts, Arun and their team has taken a lot of efforts to do this. I mean, we are also busy with so many other activities, right? But we wanted to do this workshop before you leave, so that you get an understanding of and you are able to choose those subjects to study in your fifth semester and so on. So I mean, whatever is gone is gone. I mean, but when you come back, when we do these workshops, I wish that all of you come participate and derive value out of that. Okay. Now, when I met you in the hostel or otherwise in other occasions, I've been telling you, you are a very important batch for us because you are the first batch of students coming back after COVID, and you lost 3 semesters in COVID. And, we want to put our best efforts to see that you all do well in your 3rd year, 4th year, and get you good placements or good higher study opportunities. I've been telling you, right now we are closely, about 90% of the students are placed, and we have done average of 14 lakhs per annum as of now, with the highest salary of 81 lakhs. Okay, and for a class size like this, maybe another institute is doing better than us because they have very less students and they are able to do it probably slightly better average or whatever. But for us, from 12 lakhs last year to 14 lakhs this year is a reasonably good achievement. You may wonder the statement I'm making. When your batch comes, our target is 20 lakhs average salary. 20 lakhs average salary. Now our target next year, this year target was 15 lakhs, but we couldn't do 15 lakhs. We are now allowing second jobs to students to improve our average. Now our target will be 17, 18 lakhs for the next batch, and our target for your batch is 20 lakhs. Now it's not about money, it's about the value that our graduates are able to create to the industries, and that is a reward that you get. And there are other activities that we are planning. Lot of funds are available when you come to 3rd year. There are a lot of funds available for student development activities through various clubs. I wish that this batch makes a complete difference in IIIT CCT, and you emerge as a good batch of students 2 years from now. And I just want to say it again and again to you to ensure that it's there in your mind and you participate in all the activities and very well. Okay. So with that, I'll stop. And I once again thank my entire team, Arun, Priyambada, Piyush, and Anushree, Rakesh, everybody for their efforts. And I'm sure that some of these speakers, you can definitely through Arun or somebody, you can write, ask for internships, ask for what's happening in the companies, and is there an opportunity to collaborate with them? All that you can do. And now we had actually, for computer science students, we had planned 2 more workshops, but some of we were not able to, get that organized. One is in data science, the other one is on cybersecurity. These workshops we are planning. You take a break after the exam, maybe after 2 weeks or so, on a Friday evening, Saturday morning like this, we will, with two weeks gap, we will organize 2 more workshops for you to prepare yourself for your 3rd year and 4th year. Okay, I only wish that you participate, although you will be at home or you will be doing some work, but still keep those Friday afternoon, Saturday forenoons free. We will have 2 more workshops, and we will have 1 more session little later before you come here on things that you want in the campus. Even now you can email me if you have certain things that you want in the campus when you come back. And otherwise also we will have a separate session with all of you along with Computer EC students on things that you want to have in the campus. Okay. I'm sure there are no questions or clarification from students. If it is not there, we can close here. Arun, you just want to ask if anybody wants to talk for 2 minutes, not more than 2 minutes. We can keep the floor open if anybody wants to talk.
Sure.
Yes, anybody's.
Anything that you want to share?
Yeah. Anything wants to share something or ask something to Sir, can go ahead. Yes. AC.
What is that?
AC. They're asking for AC.
AC. Yeah. We are working on it. We have already given a contract. The fellows are here already, and maybe I'm sure that in the next 1 week or few days we will get it ready.
Yes, sir.
Naman, sir.
Naman is asking something.
Good afternoon, sir. Sir, like the SLC member of our UG told us that the Wi-Fi will be fixed within a week. So like nothing has been done, sir, till now. The corner room, sir.
Yeah. Oh, your Wi-Fi in the
Yes,
first.
sir. Yes, sir.
Okay. Okay. But we have talked about it. Our IT team, head by Himanshu, suggested to buy Wi-Fi repeaters, and I also approved the Wi-Fi repeaters to be bought. Maybe it is on the way. We will get that fixed.
Yeah,
Maybe
fine.
one or 2 days.
Fine.
I have already approved the buying Wi-Fi repeaters.
Okay. Thank you, sir.